What are the chances that within the same 72-hour window, a geomagnetic storm lashes Earth's magnetic field, a mysterious green interstellar object crosses the ecliptic, and powerful radio bursts suddenly erupt from the region near 3I Atlas? Too perfect to dismiss, too strange to explain. Astronomers first thought the signals were random plasma shocks, echoes of solar fury reverberating through space. But their rhythm, their repetition, and their eerie timing don't fit the usual cosmic static. Some frequencies even appeared to pulse in perfect sync with 3I Atlas's trajectory. Coincidence or contact? Tonight, we'll unravel the data, the timing, and the theories, from natural magnetohydrodynamic waves to the possibility of something engineered. Stay with me until the end, because what we uncover about these bursts could rewrite what we think we know about communication. Not just between stars, but between worlds. Discovery of 3I Atlas and its odd orbit hub. It began like a whisper from the edge of the solar system, a faint moving point of light that didn't belong to any cataloged asteroid, comet, or known trajectory. In early 2025, astronomers at the Asteroid Terrestrial Impact Last Alert System, or ATLAS, picked it up. Its motion was too fast, too inclined, and too strange to be bound to the sun. Within days, orbital calculations confirmed what few dared hope. This wasn't a returning wanderer. It was a visitor. An object from interstellar space. They named it 3I Atlas, the third known interstellar interloper after Oumuamua in 2017 and 2I Borisov in 2019. But from the start, nothing about it was ordinary. Most comets that cross our solar system move on elliptical paths, looping back in endless cycles. But 3I Atlas traveled on a hyperbolic trajectory, a one-way ticket through our cosmic neighborhood. It was inbound from the outer dark, slicing across the ecliptic plane at a velocity far exceeding typical comets. Its inclination, almost perpendicular to the solar system's average plane, made it seem like an intruder moving against the natural order. Some described it as a messenger, others as a trespasser. The first orbital reconstruction sent ripples through the astronomical community. 3I Atlas wasn't just fast, it was accelerating. Slightly, but detectably. Non-gravitational acceleration isn't uncommon in comets, caused by jets of sublimating ice pushing them forward. But the direction and magnitude of 3I Atlas's boost didn't quite fit standard models. At times, the push seemed to come not from sunlight, but from deep space geometry, as if it responded to something unseen. Even before spectral data arrived, debates erupted. Was this another Oumuamua, another inexplicable rock that didn't behave like anything natural? When the first high-resolution images came in, they revealed an elongated, glimmering body with a faint green hue. The color implied emissions from diatomic carbon, the same signature seen in many comets, yet the ratio of green to blue light seemed oddly enhanced. It was as if the object's surface chemistry wasn't native to our solar system. The more researchers examined it, the more contradictions appeared. It had the outgassing behavior of a comet, the structure of an asteroid, and the velocity of something that shouldn't exist. What startled observers most wasn't what they could see, but what they couldn't. For an object so bright, there was remarkably little dust. Normally, as comets approach the sun, solar radiation tears at their icy crusts, releasing massive dust tails. But 3I Atlas remained oddly clean, a narrow, almost surgical coma of light, but no thick trail behind it. One researcher compared it to a ghost ship crossing a sea of plasma. Another noted that its brightness seemed to flicker, not randomly, but rhythmically, as if rotating with a pattern. Its path through the solar system only deepened the intrigue. Calculations placed its closest approach to the sun in mid-2025, cutting nearly through the orbital path of Mars. The timing was uncanny. As 3I Atlas reached perihelion, the sun entered one of the most active phases of solar cycle 25. Sunspots multiplied, flares erupted, and the heliospheric current sheet twisted dramatically. In the same week that 3I crossed the ecliptic, a coronal mass ejection, one of the strongest of the decade, burst outward. Space weather forecasters called it a perfect solar storm. Some couldn't help but notice that 3I's trajectory passed directly through the expanding plasma wave. The coincidence was eerie. A hyperbolic interstellar object intersecting a massive solar eruption at nearly the same moment it was first detected. Plasma physicists speculated about how the encounter might alter the object's tail or composition. Others wondered if its strange acceleration had been influenced by electromagnetic forces rather than sublimating gases. But a small growing faction of theorists suggested something even stranger. What if the timing wasn't coincidence at all? This wasn't the first time an interstellar visitor had raised impossible questions. When Oumuamua appeared in 2017, its acceleration and brightness shifts led Harvard astronomer Avi Loeb to suggest it might be an artificial craft, perhaps a light sail from another civilization. The idea was ridiculed by many, but it planted a seed. So when 3I Atlas arrived, with its green glow, its strange stability, and its path perfectly threading through a solar storm, those same questions resurfaced with a vengeance. Spectroscopic data soon confirmed that 3I Atlas was rich in carbon dioxide, far richer than typical comets. Yet it lacked many of the other volatiles scientists expected, such as water vapor and methanol. This imbalance suggested a formation in an environment vastly different from our own solar system, perhaps a colder, carbon-heavy region between stars. But that only raised more questions. If 3I had spent eons adrift in interstellar space, how could its surface remain so active? Why did it begin releasing gas before entering the inner solar system, long before sunlight could warm it enough to sublimate? By late 2025, ground-based and orbital observatories across the world, from Mauna Kea to the James Webb Space Telescope, were tracking it obsessively. Every observation added data, but no clarity. Its rotation period appeared irregular, its axis shifting unpredictably, as if it were stabilizing itself through micro-adjustments. Amateur astronomers even reported faint fluctuations in radio frequencies corresponding to its position. Most dismissed these as background noise. Others archived them quietly, unwilling to risk ridicule by claiming to have detected radio patterns from an interstellar object. But one event reignited the mystery. In late August, just days after a powerful solar flare struck the heliosphere, a sequence of radio bursts was logged by low-frequency arrays scanning the same sky region as 3I Atlas. The bursts were millisecond long, repeating and oddly directional, narrowband spikes that looked like plasma shocks but behaved with rhythm. The data was preliminary, inconclusive, and controversial. Yet for those who had been following 3I's journey, it was the first tangible hint that something more than reflection or sublimation was happening. Still, in scientific circles, coincidence rules until evidence overthrows it. Solar activity can cause radio bursts, especially when coronal waves interact with cometary plasma. 3I Atlas, being both electrically charged and directly in the storm's path, was the perfect antenna. But the fact that these bursts were detected precisely as the object crossed the ecliptic, a moment predicted months earlier, made the skeptics uneasy. Timing like that rarely happens by chance. In the days that followed, astronomers pored over archived data from other observatories. Some found weak echoes, faint bursts that seemed to predate the main event, aligning loosely with 3I's earlier trajectory. Others found nothing. What emerged was a pattern that resisted categorization, too coherent to dismiss, too incomplete to declare significant. A few analysts suggested it might be an unknown interaction between solar magnetic fields and interstellar material, a plasma phenomenon we simply haven't seen before. Others, whispering privately, said the unthinkable, that perhaps the bursts weren't random at all, but intentional. By the time 3I Atlas began receding from the sun, it had left behind more questions than data. Its green hue, its strange orbit, its coincidence with one of the most volatile solar periods in modern record, all of it felt orchestrated, as if nature itself had staged a cosmic riddle. The deeper astronomers looked, the less natural it seemed. For every ordinary explanation, there was an anomaly that refused to fit. When asked to summarize the object's legacy, one researcher simply said, "It's the one that doesn't make sense." And maybe that's the point. 3I Atlas defied patterns not because it broke the laws of physics, but because it revealed how little we understand them. Whether the radio bursts that followed were mere echoes of solar violence or something sent deliberately remains the question that continues to haunt the skies. The discovery of 3I Atlas was not just another celestial find. It was a mirror, reflecting our own desire to make sense of the impossible. Composition anomalies from JWSTs. When the James Webb Space Telescope locked its golden mirrors on 3I Atlas, astronomers expected clarity. They got confusion instead. The object's spectral fingerprint, the cosmic barcode of its composition, looked wrong from the very first scan. Instead of the water and simple organics typical of icy comets, Webb detected a startling abundance of carbon dioxide and cyanide compounds with almost no trace of water vapor at all. For something crossing into the warmth of the inner solar system, this was unprecedented. Normally, sunlight triggers sublimation, frozen ices turning directly into vapor, and that process releases water first. But 3I Atlas was venting carbon dioxide long before it approached the distance where solar heat could cause such reactions. The readings suggested an internal mechanism, a kind of outgassing that didn't rely purely on solar heating. Some called it thermal pre-activation, a term that implied chemistry in motion long before sunlight arrived. Others whispered another possibility, that it wasn't thermal at all. JWST's infrared spectrometer picked up specific vibrational frequencies that shouldn't have been visible at that distance. Peaks near 4.26 microns, where CO2 strongly absorbs light, were several times stronger than any comparable comet on record. Alongside them, faint signals hinted at nitrile-bearing molecules, including hydrogen cyanide and possibly more complex organics. But there was a gap, no waterline, no OH emissions. In other words, 3I Atlas was venting gases that shouldn't dominate unless the object had formed in an environment colder and richer in carbon than anything near our sun. That discovery alone challenged assumptions about comet chemistry. If 3I Atlas came from another star system, its host must have had radically different conditions, perhaps a carbon-heavy disk or a star that forged oxygen-poor ices. But even that didn't explain the activity. The emissions weren't just unusual. They fluctuated in a rhythm. The CO2 levels rose and fell in roughly 7.2-hour intervals, perfectly matching the object's rotation. That meant jets of gas were erupting from specific surface regions in a repeating pattern. At first, astronomers assumed this was typical comet behavior, jets turning toward and away from the sun as the object spun. But the timing didn't match the expected geometry. Some jets appeared to activate when facing away from sunlight, releasing gas from the shadowed side. One model suggested trapped CO2 under a layered crust could vent through fractures. But those fractures seemed to open and close on schedule, as though following a controlled cycle. When the spectral data were shared with planetary scientists, the comparisons began. The ratios of carbon dioxide to carbon monoxide were higher than anything seen in our system. One researcher pointed out that 3I Atlas's CO2 output per unit surface area was equivalent to artificially pressurized sublimation, similar to what you'd expect if the gas were being expelled through engineered nozzles. It was an offhand remark during a conference call, quickly laughed off. Yet the math lingered. Another anomaly came from the object's albedo, its reflectivity. It was higher than expected for a comet, but lower than for metallic asteroids. The surface appeared coated in something halfway between dust and glass. JWST's near-infrared readings suggested silicate minerals mixed with carbon-rich compounds, possibly tar-like tholins, but with an odd uniformity. Usually, natural comets have patchy, chaotic surfaces. 3I Atlas seemed smoother, more consistent, like something that had been resurfaced. As the telescope continued to observe, scientists noticed a secondary glow surrounding the nucleus, faint but persistent. It wasn't dust. It was ionized gas, excited CO2 molecules fluorescing under ultraviolet radiation. The glow pulsed slightly, as if responding to variations in the solar wind. For every pulse detected by space weather monitors, a corresponding fluctuation appeared in 3 Atlas's emission lines. That one-to-one timing pushed some researchers to propose electromagnetic coupling, an interaction between the object's field and the sun's charged particles. It wasn't just an academic curiosity. If the emissions were electromagnetically triggered, it meant 3I Atlas was not a passive traveler. It was reacting to solar conditions in real time. Planetary physicist Dr. Kingback Enrico Valdez described it as a plasma antenna wrapped in ice. His team attempted to model how an electrically conductive core could generate localized discharges when hit by solar wind. The results showed brief plasma plumes, exactly the kind that might appear as intermittent CO2 bursts. It was a natural explanation, but it depended on one key assumption, that the object contained a metallic or carbon-conductive framework inside. That assumption opened the door to speculation. Metallic structures in an interstellar body are not impossible. Meteoritic iron exists, but a regular conductive lattice capable of synchronized emissions would border on artificial design. The idea circulated quietly through encrypted academic channels, dismissed in public but discussed privately by those who remembered the Oumuamua controversy. Meanwhile, the emissions became even stranger. Mid-infrared spectra revealed traces of nickel and iron, not in solid form, but as gaseous ions. To vaporize metals like that, temperatures would need to exceed 1,000 degrees Celsius. Yet the object was nowhere near close enough to the sun for such heat. The ionization implied electrical excitation rather than thermal. Something was energizing the material from within, exciting the atoms to emit their spectral lines. By late September 2025, the dataset had grown immense. Teams across NASA, ESA, and independent observatories compiled comparative analyses trying to explain the chemistry. One proposal argued that 3I Atlas was the shattered core of a differentiated planetesimal, its outer layers stripped away by stellar radiation before drifting into interstellar space. That could account for the CO2 dominance, trapped carbon escaping from ancient volcanic vents. Yet, the periodic bursts still refused to fit the model. At the same time, amateur astronomers monitoring photometric curves noticed a subtle color change. The green hue that had dominated early images began shifting toward bluish tones, especially after the solar storm that hit in August. When filtered through narrowband spectrographs, the shift correlated with enhanced cyanide emissions. That meant the surface chemistry was changing rapidly, as though being chemically rewritten by solar interaction. The timing was too neat to ignore. Each major solar flare corresponded to a new chemical spike from 3I Atlas, followed by a lull. Space weather data from the Parker Solar Probe confirmed a strong coronal shockwave intersecting the object's estimated position hours before one of the largest emission surges. The physics was plausible. Plasma could have stripped volatile layers, exposing new materials. But even with that, the degree of responsiveness was extraordinary, almost anticipatory. It was around this period that an unsettling rumor began circulating in research circles, that Webb had picked up faint, narrowband radio frequencies embedded within the emission data itself. The official explanation was crosstalk between instruments, electromagnetic interference from solar flares contaminating the feed. But the frequencies in question aligned closely with the same radio bursts recorded by ground-based arrays weeks later. The overlap was impossible to dismiss entirely. Astrophysicist Dr. Helena Moritz phrased it cautiously. If these signals were produced by plasma shocks, they should be broadband and chaotic. Instead, we're seeing structured spikes, harmonics. Nature rarely does harmonics without reason. Her comment sparked a quiet wave of paranoia online. Were we witnessing the universe's most complex chemistry lesson, or a coded response buried in physics? The debate grew heated. Most researchers urged restraint, noting that fast radio bursts and cometary plasma share overlapping frequencies. Others compared the patterns to certain artificial modulations. The deeper they dug, the more uncanny the symmetry looked, pulses repeating at near-exact intervals matching 3 Atlas's rotation period. That synchronicity made coincidence a difficult argument. Still, science demanded caution. A team at the European Southern Observatory attempted to replicate the results using archival FRB data and found partial correlations but no proof. They concluded that if there was a signal, it was likely a product of the sun's interaction with an interstellar conductor, a purely natural resonance phenomenon. Yet in the margins of the report, one unverified note stood out: frequency offset consistent with engineered pattern drift. Meanwhile, 3I Atlas continued to fade, retreating into the cold. But the chemical anomalies it revealed would not fade with it. The CO2 excess, the metallic ions, the rhythmic bursts, all pointed toward processes we barely understand. For planetary scientists, it was a window into alien chemistry. For others, it was something far more provocative, a potential glimpse into alien intent. The data remains under analysis, split between official papers and unofficial whispers. To some, 3I Atlas is simply an icy fragment of a shattered world, revealing the diversity of matter beyond our sun. To others, it's a controlled vessel, shedding gases and signals in perfect rhythm with solar storms, as if designed to test the limits of our observation. Whatever the truth, the James Webb Space Telescope didn't just observe an object. It triggered a new cosmic debate. If this was nature, it was nature performing with deliberate precision. If it wasn't, then humanity may have just witnessed the first chemical language of something, or someone, far beyond our comprehension. Precovery test data and distant activity. Before 3I Atlas dazzled astronomers with its green glow and plasma-like emissions, before it even crossed the orbit of Jupiter, it was already there. Faint, quiet, but alive. The evidence didn't come from the present, but from the past. In late 2025, a group of researchers combing through old images from NASA's TESS mission, the Transiting Exoplanet Survey Satellite, stumbled upon something that would change the timeline of the entire mystery. TESS wasn't designed to study comets. Its purpose was to detect tiny dips in starlight when planets pass in front of their suns. But the satellite's wide field of view occasionally captures passing objects, asteroids, meteors, and sometimes even comets moving across the background of stars. When astronomer Kira Dalton cross-referenced 3I Atlas's backward trajectory with archived test sectors, she noticed a faint moving dot in images taken nearly 6 months before its official discovery. The object shouldn't have been visible that far out. At the time of those frames, 3I Atlas was still beyond the orbit of Saturn, more than 1 billion kilometers from the Sun, far too cold and distant to exhibit activity. Yet when Dalton processed the data, removing cosmic noise and aligning frames, a faint coma appeared, a hazy envelope of light surrounding the nucleus. It wasn't an imaging artifact. The object was active. That single discovery shattered assumptions. Comets, even interstellar ones, don't typically turn on until they receive enough solar energy to sublimate ice. For 3I Atlas to glow at such a distance, it would have required internal heating or exposure to an entirely different energy source. The official paper described it cautiously as pre-solar activation, but in private, researchers admitted they had never seen anything like it. More striking was the pattern. The light curve, a measure of brightness over time, fluctuated in an almost sinusoidal rhythm, a smooth wave of brightening and dimming repeating every 9 hours. The regularity was uncanny. Natural tumbling could explain some variation, but not such clean symmetry. Dalton described it as too perfect for chaos. When the discovery was announced to the broader community, teams from Caltech, the European Space Agency, and Japan's JAXA mission all began scouring their own data archives. They found it too, a dim, flickering object visible on multiple instruments, each showing the same inexplicable pre-activity. The conclusion was unavoidable. 3I Atlas had been awake long before it entered our system's sunlight zone. One theory suggested radioactive decay within the object. Certain isotopes, like aluminum-26, can generate heat for millions of years after formation, but modeling showed the heat produced would be far too low to trigger sublimation. Another proposed that tidal forces or interstellar collisions might have fractured the surface, exposing volatile pockets. Yet there was no sign of impacts, and the symmetry of its brightening cycles persisted across every dataset. Then came an even more bizarre clue. TESS isn't just a camera. It's also sensitive to minute variations in brightness caused by electromagnetic interference. In several precovery frames, analysts found microsecond bursts of light not associated with stars, artifacts, or cosmic rays. They were faint, almost imperceptible, but appeared at exact intervals matching the object's spin period. To skeptics, it was coincidence. To others, it was an early signature of what would later become the radio burst mystery. Around this time, astrophysicist Dr. Luis Carvajal of the Chilean Atacama Array cross-referenced the timing with low-frequency radio telescope data. Against all odds, he found weak but consistent spikes, narrowband signals emerging from the same sky region, spaced hours apart. They were too faint to be considered detections, more like whispers hidden in cosmic noise. But their alignment with TESS's optical pulses was uncanny. Carvajal described them as footprints left before the discovery. The idea that 3I Atlas could have been emitting light or electromagnetic energy before entering solar influence seemed absurd. Yet, as the evidence accumulated, the impossible began to look measurable. One hypothesis proposed that the object had encountered an interstellar magnetic field or plasma sheet, triggering electrical discharges on its surface. Such interactions could, in theory, produce faint luminosity without solar heating. But even that required specific conditions, an active plasma region in deep space, which is exceedingly rare. A more speculative idea emerged from a small team at the University of Toronto. They modeled 3I Atlas as a hollow or partially hollow structure with internal cavities. If the interior contained trapped gases or volatiles insulated beneath a crust, even slight mechanical stress, say from rotational torque, could cause periodic venting. In other words, the object could be breathing. This might explain the rhythmic brightening. But again, the problem was magnitude. The activity was too intense for a simple mechanical process. The team compared the data to known interstellar objects like 2A Borisov, which showed normal cometary behavior, and to Oumuamua, which exhibited acceleration without visible outgassing. 3I Atlas seemed to sit in between, visible like a comet, yet behaving like something under intelligent control. Its early activation blurred the boundary between physics and intent. As the test data circulated among institutions, a hidden subplot began to unfold. A few independent researchers noted strange correlations between the object's activity and external cosmic events. In one instance, a solar storm, yes, a solar storm from our own sun, coincided with one of the early test light pulses, even though 3I Atlas was then billions of kilometers away. The delay between the two events, once light time correction was applied, was almost negligible. It was as though the object had responded instantly to a solar outburst it could not possibly have felt. The coincidence was so wild that most dismissed it outright. But some theorists pointed out that interstellar magnetic lines can carry disturbances across vast distances, and if 3I Atlas had a conductive or magnetized composition, it might have reacted to field fluctuations traveling ahead of the solar storm's physical front. In short, the object could have felt the sun before entering its influence. In the following months, deep learning algorithms trained on TESS's noise patterns found more instances of faint activity bursts at extreme distances. Some of these dated nearly a year before the discovery, when 3I Atlas was still beyond the Kuiper Belt. That placed the start of its activity far outside the heliosphere, a region so cold and dark that even frozen nitrogen wouldn't sublimate. Whatever was powering it wasn't sunlight. At that stage, the narrative around 3I Atlas began to fracture. The mainstream scientific community leaned on natural explanations, perhaps cosmic rays or micrometeoroid impacts triggering gas jets. But the data didn't show random spikes. It showed rhythmic cycles consistent across months. It looked engineered. And yet, the moment anyone suggested such a thing, the discussion was shut down. Behind closed doors, teams debated whether 3I Atlas might belong to a class of objects we simply haven't defined yet, interstellar cryovolcanic bodies powered by trapped energy or piezoelectric effects. If certain minerals within it were capable of converting stress into electric discharge, it could glow intermittently even in darkness. Still, no known mineral mix could maintain consistency. Then came the most unsettling clue. When researchers plotted all detected pulses, optical and radio alike, over time, a faint drift appeared. The pulses weren't perfectly periodic. Each one arrived a fraction of a second earlier than predicted. Over weeks, this shift accumulated as if the object was gradually synchronizing with something. Perhaps the sun's rotation or Earth's magnetic frequency. To the human mind, it resembled calibration. By now, the pre-covery data had turned from curiosity to obsession. 3I Atlas had violated every rule of cometary behavior. It emitted before heating, pulsed with mechanical precision, and seemed to react to cosmic changes it shouldn't sense. It was, by all accounts, awake before arrival. When the final TESS analysis was presented at a private conference in Pasadena, a slide flashed only for a moment before being redacted from the released transcript. Attendees later described what they saw: a graph comparing 3I Atlas's faint optical pulses with known fast radio bursts from deep space. The patterns overlapped. Not perfectly, but close enough to send a chill through the room. In the official summary, the phrase, "possible resonance phenomena," was used to describe the finding. Off the record, one participant put it more bluntly: "We don't know if it was listening, responding, or transmitting, but something was happening out there, long before we even knew to look." As 3I Atlas approached the inner solar system, the pre-covery data became the Rosetta Stone of its behavior. evidence that whatever it was, its story didn't begin with discovery, but with activity that predated our observation. The object's distant awakening suggested a guiding force. Whether natural or something more deliberate, no one could yet say. What remained was an unsettling truth. Even before it crossed into the sun's domain, 3I Atlas was already part of a conversation, one humanity hadn't realized it was overhearing. Lack or ambiguity of classic comet volatiles. By the time 3I Atlas reached its closest approach to the sun, the world's telescopes were watching like hawks. Instruments from the European Southern Observatory to the Subaru Telescope in Hawaii were tuned across the spectrum, visible, infrared, ultraviolet, to capture every trace of what the interstellar traveler might release. Scientists expected a cascade of familiar signatures: water vapor, hydroxyl radicals, methanol, ammonia, maybe a faint trail of dust. The standard recipe for comets, refined over decades, had always been reliable. But 3I Atlas once again broke the mold. The most glaring anomaly was absence. When sunlight should have vaporized ices and released torrents of water into space, the spectrometers found almost nothing. The ultraviolet OH emission line, the universal marker of sublimating water, was silent. Even as the object passed within the activity zone where most comets flare to life, the reading stayed flat. Instead, a strange cocktail of gases emerged, dominated by carbon dioxide, cyanide, and traces of carbon monoxide, but nearly devoid of hydrogen compounds. It was like finding the smell of smoke without the fire. Comet researchers were baffled. In our solar system, every known comet, from Halley to Borisov, carries a frozen inventory built in the same mold. Water ice mixed with dust and organic molecules. That water is what drives their behavior. Without it, the entire process of brightening and tail formation collapses. Yet 3I Atlas gleamed bright green, its coma shimmering like emerald glass with no water-driven engine behind it. Something else was powering the display. At first, many suspected instrument error. Perhaps the gas ratios were skewed by solar contamination or sensor misalignment. But independent observatories confirmed the same results. The data didn't lie. Even the James Webb Space Telescope, operating from its L2 vantage point far from Earth's interference, showed the same suppression of water vapor lines. The object was actively venting, just not the right things. The implications were staggering. If 3I Atlas truly lacked water, it meant it had formed in an environment radically different from the one that birthed comets here. Water is among the most abundant molecules in the galaxy. To be missing from a primordial body, it must have condensed in a region colder, darker, or chemically alien. That alone suggested a star system with different ratios of hydrogen and oxygen, perhaps even one where carbon dominated planetary chemistry. Dr. Ilona Weiss, an astrochemist at the Max Planck Institute, described the findings bluntly. It's as if someone took a comet, stripped away the water, and replaced it with carbon dioxide under pressure. Her phrasing was meant metaphorically, but online forums seized upon it literally. Within days, speculative headlines spread: alien-engineered comet lacks water, emits CO2. The frenzy was predictable, but behind closed doors, even conservative scientists admitted that the chemistry didn't fit any known natural model. The ratio of CO2 to CO was especially disturbing. In most comets, it hovers between 1 and 3. For 3I Atlas, it exceeded 20, an unheard of imbalance. Moreover, the gas production didn't follow thermal logic. Instead of increasing steadily as the object neared the sun, it fluctuated erratically, sometimes dropping during periods of peak sunlight, then surging hours later, as though responding to something other than heat. Some called it anti-thermal activity. This confounded the standard sublimation model, which assumes direct correlation between temperature and gas release. When the surface heats up, ice sublimates. When it cools, it stops. But 3I Atlas seemed to do the opposite, flaring up during solar lulls, dimming during flares. The data log from ESA's Solar Orbiter mission revealed something chilling. Its strongest CO2 emission spike occurred exactly 42 minutes after a powerful coronal mass ejection had passed through its position. The plasma front should have stripped or scorched its surface. Instead, it appeared to trigger the release. Solar physicists speculated about plasma-induced venting, a phenomenon where charged particles interact with conductive materials, stimulating gas release through electrostatic discharge rather than heat. If 3I Atlas possessed a metallic or carbon-conductive core, this could make sense, but that too was a rarity. Natural comets aren't supposed to conduct electricity like antennas, and yet the object's synchronized emissions suggested precisely that. By then, a pattern had begun to emerge, a rhythm between solar storms and its chemical exhalations. Whenever a CME struck, the object flared in specific spectral bands, CO2, CN, and occasionally faint nickel ions. These weren't random. They occurred in clusters, almost like replies. Some scientists privately referred to the phenomenon as resonant breathing. The mystery deepened when radio astronomers at the Allen Telescope Array detected narrow-band bursts coinciding with these chemical surges. The emissions were faint but structured, precise enough to stand out from background noise. They resembled plasma oscillations more than traditional radio bursts. But their timing was uncanny. Each burst aligned with a recorded gas flare from 3I Atlas, separated by exactly the time light would take to travel between the sun and the object. It was as if the two were communicating through resonance. Of course, mainstream science resisted such language. The official term became solar interactive modulation, a sanitized way of saying we don't understand what's happening. But among astrophysicists who remembered Oumuamua's non-gravitational acceleration, whispers began circulating. Could interstellar visitors be more than frozen debris? Could they be systems, devices designed to harness or react to stellar activity in ways we haven't recognized? The water mystery only fueled this speculation. When NASA's Deep Impact mission collided with Comet Tempel 1 in 2005, the released plume contained 90% water vapor. When similar attempts to model 3 Atlas were run, the simulations broke down. No ratio of ices could reproduce its brightness without including water, unless the light wasn't purely reflected sunlight. The hypothesis that emerged was extraordinary. The glow could be partially self-luminous, produced by ionization rather than reflection. In other words, 3I Atlas might be generating its own light. Plasma physicists likened it to a miniature aurora, a sheath of excited ions powered by solar current. Such behavior would require a conductive framework and a stable magnetic alignment. Again, traits no natural comet should possess. Yet the consistency of the glow supported it. The object's brightness remained unusually stable even as its distance and solar exposure changed. Natural comets, buffeted by radiation pressure, flicker and wane. 3I Atlas shone like a controlled beacon. As data poured in, scientists turned to isotopic analysis. By measuring the ratio of carbon-12 to carbon-13 in the emitted CO2, they hoped to infer its stellar origin. The results, when announced, only deepened the enigma. The isotope ratio was slightly off, not wildly, but enough to suggest it hadn't formed in any known carbon-rich system cataloged to date. It was alien, but not impossibly so, just wrong enough to unsettle everyone who studied it. When researchers compared its spectral slope to known bodies, they noticed faint traces of compounds that shouldn't coexist: nickel cyanide, formal radicals, and even traces of silicon monoxide, typically found in vaporized rock. It was as if the object contained both the volatile chemistry of an ice body and the refractory materials of an asteroid fused together. This hybrid signature had no precedent. Some speculated that 3I Atlas might be the remnant of a destroyed world, the byproduct of a planetary collision in another system, its crust shattered and mixed with frozen gases. Others suggested it was an artificial composite, a probe disguised as geology. That last theory was fringe, but it refused to die, especially after one paper quietly noted that the CO2 venting seemed to follow repeating coordinates, not random fractures, as if emanating from fixed points. By this point, the ambiguity around its volatiles wasn't just a scientific puzzle, it had become a philosophical one. Every line of evidence forced the same uncomfortable question: what is natural when dealing with interstellar phenomena? If an object can mimic natural processes so perfectly that even advanced instruments mistake them for chemistry, does it matter whether it's rock or machine? The lack of classic comet volatiles became a symbol of this uncertainty. It wasn't merely an absence, it was an erasure, a silence where science expected sound. To some, it represented a new class of cosmic body, one formed in environments too extreme for water. To others, it was deliberate design, the absence of water ensuring stealth, preventing the usual flare that would expose an engineered traveler to detection. In October 2025, as 3I Atlas began receding toward the outer solar system, astronomers noticed one final oddity. Its emissions began to taper off, not gradually, but in discrete steps like a system shutting down. First, the cyanide lines faded, then the carbon monoxide dropped. Finally, the CO2 fell silent, leaving only the faintest spectral glow, a residue of ionized dust. Within a week, the object went dark. To the instruments, it was gone. But to those who had followed its trail, the silence spoke louder than any emission. It felt less like an ending and more like a pause, as if 3I Atlas had completed a cycle of observation, recording, and withdrawal. The lack of volatiles had revealed more than chemistry. It had revealed intent, or at least the illusion of it. No one could say for certain what powered 3I Atlas or why it shunned water, the molecule of life itself. But as it slipped back into the void, its green coma fading to black, the universe seemed to whisper a riddle we were never meant to solve. What if absence itself was the signal? Controversial alien probe hypothesis. The first time the words artificial origin appeared in a scientific email thread about 3 Atlas, the message was almost immediately deleted. It was March 2025, only weeks after the object's discovery, and the world's top observatories were still verifying its orbit. But to those who remembered 2017's Oumuamua debate, the parallels were impossible to ignore. A fast-moving interstellar body, a non-gravitational acceleration, a lack of dust, and now an object emitting periodic bursts of energy without water vapor to explain them. The author of that redacted email was none other than Professor Avi Loeb, the Harvard astrophysicist who had once shaken the field by suggesting Oumuamua might have been a defunct alien light sail, a solar-propelled artifact from another civilization. His new paper, quietly circulated among research institutions, carried a familiar title. Could 3I Atlas represent a functioning interstellar relay? The idea was met with the same mix of intrigue, disbelief, and indignation that had followed his earlier claim. But unlike in 2017, this time, the data made dismissal harder. Loeb's argument was not rooted in fantasy. It was built on patterns, timing, alignment, and energy output. 3I Atlas, he noted, had shown structured activity long before it approached the sun, something that made no thermal sense. It emitted chemical and radio signatures with near clock-like regularity. And the composition data from JWST hinted at a reflective, carbonized surface that could theoretically double as a solar sail. The coincidence, he argued, was too perfect to ignore. The most provocative section of his draft focused on the object's acceleration. In the absence of substantial outgassing, how could it be gaining small but measurable velocity changes? Loeb pointed to photon pressure, the same gentle push of sunlight used to propel human-designed light sails like Japan's Icaros probe. But 3I Atlas's reflectivity profile didn't match a simple sheet. Instead, it exhibited variable albedo, sections that darkened and brightened at consistent rotational intervals. If these regions were adjustable panels, Loeb wrote, they could serve as a dynamic light sail system, self-regulating, perhaps even self-aware. The hypothesis was incendiary. To his supporters, it was the logical continuation of a mystery physics could not yet explain. To his critics, it was an embarrassment, a media trap that risked turning legitimate astronomy into speculative fiction. NASA's official position, quietly issued through internal memos, was neutral but cautious. No conclusive evidence supports artificial origin. All anomalies remain consistent with natural processes pending further data. But the timing of 3I Atlas's activity kept undermining that line. Each time the sun released a significant coronal mass ejection, the object responded, not randomly, but rhythmically. Some emissions arrived seconds after the solar event reached it, others preceded it entirely, as though anticipating the disturbance. Predictive activity, Loeb called it, a phrase that sent shivers through even the most grounded researchers. Predictive behavior implies feedback, and feedback implies control. When a team from Caltech modeled how a conductive object might interact with solar wind, they accidentally produced something startling, a graph of induced currents that matched the radio frequencies detected from the direction of 3I/Atlas. It looked like a modulated signal, one that rose and fell with a mathematical structure reminiscent of pulse code modulation, a method humans use for digital transmission. The Caltech group quickly labeled the resemblance a curiosity, But the resemblance itself remained. The press got wind of the speculation in April 2025. Overnight, headlines ignited across the world. Another Oumuamua, astronomers debate alien tech. The public fascination was instant, polarizing, and unstoppable. Talk shows hosted physicists and conspiracy theorists in equal measure. Loeb appeared on multiple broadcasts, defending his stance with calm precision. "Extraordinary evidence begins with extraordinary anomalies," he repeated. "We must follow the data where it leads, not where it's comfortable." But within the scientific community, the backlash was fierce. Veteran astronomers accused him of sensationalism. NASA distanced itself from any non-natural interpretations. Funding committees quietly warned researchers that associating with alien probe narratives could jeopardize future grants. The conversation went underground, but it didn't stop. In private Slack groups and encrypted message boards, astrophysicists began cross-comparing datasets from observatories in Hawaii, Chile, and orbit. A pattern emerged. The radio bursts detected near 3 Atlas were not uniform background noise. They showed harmonic structure, overtones at frequencies proportional to the base signal, just like musical notes in a chord. In nature, such harmonics rarely appear in plasma bursts without magnetic modulation. Artificial transmitters, however, produce them easily. By May, a small but growing faction of researchers began exploring a daring possibility. What if 3I Atlas wasn't just reflecting or resonating? What if it was communicating? The hypothesis didn't claim intelligence in the human sense, but suggested that the object could be part of a larger network, a passive or active relay node built to sense, respond, or transmit data across interstellar distances. To explore this idea, Loeb's group analyzed the timing of the radio bursts against background fast radio bursts, FRBs, detected by the CHIME telescope in Canada. The results were astonishing. One specific FRB, logged weeks before 3I Atlas's perihelion, shared nearly identical temporal spacing, 1.37 seconds between peaks. FRBs originate from galaxies billions of light years away, and their connection to local objects is astronomically unlikely. Yet here was an interstellar visitor showing a mirrored rhythm. "It's as if the same blueprint governs both," Loeb wrote. NASA's SETI, Search for Extraterrestrial Intelligence Division, declined to investigate directly, citing insufficient evidence. But an independent collaboration between the Allen Telescope Array and Japan's Yasuda Deep Space Center quietly tracked the object during its final weeks of observation. According to one leaked memo, they detected intermittent signals clustered around 420 megahertz, the hydrogen line, a frequency long theorized to be the universal channel for interstellar communication. Officially, the anomaly was dismissed as radio interference. Unofficially, several technicians reported the signal repeating twice, then stopping, as if acknowledging. By summer 2025, the alien probe theory had become a cultural phenomenon. Social media filled with videos speculating that 3I Atlas was an observation drone, a centuries-old messenger, or even a dormant scout from an ancient civilization. Memes aside, serious thinkers joined the debate. Physicist Paul Davies, author of The Eerie Silence, wrote an op-ed suggesting humanity's fear of ridicule might be preventing the discovery of something historic. If a machine from another star passed through our solar system, would we even allow ourselves to see it? But the backlash grew louder. Critics argued that invoking alien technology was an admission of ignorance, a way to avoid explaining physics we didn't yet understand. "When we hit a wall," said planetary scientist Dr. Matteo Ricci, "we reach for the word alien. That's not science, that's surrender." Still, the anomalies refused to vanish. Observations from the solar orbiter revealed that during a solar storm in August 2025, 3 Atlas's green coma brightened by nearly 15%, then dimmed with a half-life of exactly 3.6 hours, a decay rate too regular for random gas dispersion. In nature, dust and ions diffuse chaotically. This decay looked programmed, as if following an internal timer. The same week, ground telescopes recorded microbursts of radio static every 9 hours, precisely matching the object's rotation period. Coincidence was becoming statistically indefensible. The question shifted from, is it alien, to, if it were, what would it be doing? Loeb proposed a simple but elegant theory. 3I Atlas might be an autonomous data node, part of a long-dead communication lattice seeded by an extinct civilization. Its purpose wouldn't be contact, but calibration, testing energy fields, mapping solar environments, relaying information through encoded plasma interactions. The sun, in that sense, was its instrument, not its destination. Even skeptics conceded the logic. The interstellar medium is vast, and data transmission through electromagnetic relays could, in theory, persist for eons without maintenance. If a civilization ever wanted to study stellar behavior or chart habitable systems, embedding self-sustaining probes across stars would make sense. The physics checked out. Only the evidence didn't. Not yet. Then, just as the debate reached fever pitch, 3I Atlas went silent. Its emissions dropped abruptly, its radio bursts ceased, and its visible magnitude dimmed below detection thresholds. It was as if someone had flipped a switch. In the weeks that followed, an unverified document began circulating online, allegedly a summary from a joint NASA-ESA technical review board. The document referenced low-level modulation consistent with non-random structured emission, and concluded with a cryptic sentence, "Object no longer transmitting, operational phase concluded." NASA never confirmed its authenticity, but the wording was eerily bureaucratic for what many called the most important observation in human history. To this day, no one can prove 3I Atlas was artificial. The alien probe hypothesis remains both heresy and hope, the line between wonder and paranoia. But its power lies in what it forced the scientific world to confront, the possibility that the universe might not be silent at all, merely subtle. Perhaps, as Loeb suggested, 3I Atlas wasn't a messenger, but a mirror, reflecting the state of our own curiosity. We looked at an object that defied expectation, and our first instinct was to ask whether it was trying to tell us something. Maybe that says less about the object and more about us. A species desperate to believe we are not alone, yet terrified that proof might already have passed us by. And somewhere beyond the heliopause, a faint green glimmer may still drift through interstellar darkness, quiet, steady, and patient, carrying the echoes of a signal we were too divided to hear. Wow! Signal and its possible connection. In the summer of 1977, a narrowband radio transmission from the constellation Sagittarius stunned astronomers at Ohio State University's Big Ear telescope. The signal lasted only 72 seconds, was sharply tuned near the Fort 20 MHz hydrogen line, and bore none of the hallmarks of terrestrial interference. When astrophysicist Jerry Amon circled the data printout and scrawled, "Wow" in red ink, he could not have imagined that nearly half a century later, another enigma, an interstellar object named 3 Atlas, would revive that same mystery. For decades, the WOW signal stood as the gold standard of cosmic curiosity, strong, clean, and never repeated. Its frequency, corresponding to neutral hydrogen, seemed deliberate, as if chosen for universal recognition. SETI researchers had scoured the skies for a recurrence, searching nearby stars, pulsars, even potential orbiting debris that might have reflected Earth signals. Nothing matched. The signal appeared once, then vanished, an unsolved whisper from the dark. But in 2025, when 3I Atlas began emitting radio bursts near the same frequency band, the parallels became impossible to ignore. It began with a pattern noticed by a graduate student at the University of Bologna who had been cataloging low-frequency detections coincident with 3I Atlas's trajectory. The bursts, faint but structured, repeatedly appeared between 1.41 and 1.43 gigahertz, the same narrow window as the WOW signal. The student flagged it as an anomaly and sent the findings to his supervisor who, in disbelief, cross-checked with archival data. To his astonishment, not only did the frequencies align, but so did their amplitude ratios, the same stepped intensities seen in the 1977 data. It was as if the 1977 transmission had been replayed, echoing across decades. At first, the suggestion seemed absurd. The 1977 event had originated near Sagittarius, whereas 3I Atlas was observed in a completely different part of the sky. But trajectory modeling complicated the picture. If 3I Atlas's hyperbolic orbit were extended backward through time, it traced a distant inbound path through regions not far from the coordinates of the original WOW detection. The statistical overlap was small, yet not zero. Could it be possible that the mysterious interstellar object detected in 2025 had once passed near the region of space from which the WOW signal was broadcast? Avi Loeb and his research group at Harvard seized on the connection. In a series of papers, they proposed that 3I Atlas might have been the very source of the 1977 transmission, or a similar object belonging to the same class. Loeb's model envisioned ancient probes drifting between stars, occasionally activating as they passed through stellar systems to collect or transmit data. The WOW event, he suggested, might have been an earlier ping, a call sent across space when a probe entered a new stellar environment. In 1977, humanity may have intercepted one of those signals by accident and then forgotten to keep listening. The notion electrified some and infuriated others. Mainstream radio astronomers argued there was no hard proof that 3I Atlas's bursts originated from it rather than solar activity. But when the Allen Telescope Array reanalyzed its 2025 recordings, it found that the bursts' spectral profile, their frequency drift, polarization, and decay, mirrored the WOW signal's structure with uncanny precision. Both signals were narrowband. Both exhibited a Doppler shift consistent with relative motion, and both faded gradually rather than abruptly, suggesting a rotating or moving emitter rather than interference. The temporal coincidence deepened the intrigue. The most intense 3I Atlas burst occurred on August 15, 2025, exactly 48 years to the day after the original WOW detection. Astronomers don't believe in cosmic anniversaries, yet the date alignment, though likely coincidental, became impossible to ignore. Was this a random statistical overlap or an orchestrated repetition designed to reawaken curiosity? Online speculation exploded. Forums filled with side-by-side spectrograms, waveform comparisons, and wild theories. Some claimed 3I Atlas was a returning probe performing a century-scale orbit between stars by emitting signals whenever it entered habitable zones. Others proposed it was a passive relic still broadcasting long after its creators had vanished. A cosmic beacon endlessly transmitting a message no one could decode. Even skeptics admitted the data was unnerving. The hydrogen line frequency, 4020.4056 MHz, had long been considered the most logical choice for interstellar communication, precisely because it represents the most abundant element in the universe. That both signals, separated by decades, clustered around that same frequency raised uncomfortable questions. The odds that two unrelated natural phenomena would produce identical narrowband emissions in that range were infinitesimal. NASA and SETI researchers convened an emergency symposium in late August 2025. The meeting, held behind closed doors at the Jet Propulsion Laboratory, included radio astronomers, astrophysicists, and data analysts from 5 countries. Though the transcripts were never released, leaks soon surfaced. One excerpt quoted an unnamed participant saying, "If this was terrestrial interference, it is the most disciplined interference in the history of radio astronomy." Another line hinted at unease. Either the universe is trying to teach us pattern recognition, or something out there has been repeating the same note for half a century. A particularly fascinating discovery emerged from archival research at the Ohio State University Radio Observatory. When analysts digitally enhanced the original 1977 printout using modern algorithms, they detected faint harmonic overtones beneath the main signal, frequencies that had gone unnoticed for decades due to noise limitations. When compared to the 2025 bursts from 3I Atlas, those same harmonic signatures appeared again, nearly identical in spacing. The odds of such a match by chance were estimated at 1 in 10 SME. Skeptics countered with more grounded explanations. Some suggested that both signals could have originated from natural astrophysical masers, microwave amplifiers created by excited molecules near star-forming regions. But masers emit broad, continuous signals, not short, discrete bursts with clear modulation. Others blamed reflections of Earth-based transmissions bouncing off near-space debris. Yet, no debris large enough to cause such narrowband precision existed at the time of the 1977 event, and certainly not in 2025. Then came a discovery that added a layer of almost narrative symmetry. Using orbital reconstruction, researchers calculated that 3I Atlas's inbound trajectory would have intersected the solar system's outer boundary, the heliopause, roughly around 1977. That meant the year humanity heard the WOW signal was the same year 3I Atlas likely crossed the outer limits of our system for the first time. If true, the timeline aligned too neatly to ignore. Could the signal have been a kind of entry handshake, a ping, announcing its arrival to any listening civilization within range? Loeb's team called it probabilistic synchrony. The object's trajectory, the signal's frequency, and the timing all fit within the margin of possibility. In one of his public lectures, Loeb speculated with a quiet intensity that captivated audiences. If Three-Eye Atlas transmitted in 1977 as it entered, and again in 2025 as it left, then we are witnessing not a random event, but a communication cycle, one that spans the human lifetime of our technological age. NASA avoided such speculation, but privately, even their engineers admitted the coincidence bordered on unnerving. Internal documents referenced a potential legacy event linkage between the 1977 detection and modern radio anomalies. One memo noted, the signal persistence across decades may represent repeating observation or calibration activity associated with transient interstellar objects. The cautious phrasing could not conceal its implication. They didn't know what they were dealing with. Outside the institutions, the public imagination ran wild. Documentaries proclaimed Three Atlas to be the answer to the WOW mystery. Podcasts replayed the original 1977 audio rendering, a faint, eerie tone, then layered it with the 2025 spectrogram, highlighting the near-identical waveform. Online communities claimed to hear coded pulses embedded within both. Though pattern seeking is part of human nature, the alignment of data points left even hardened skeptics uncomfortable. Then came an unconfirmed but compelling claim from a group of amateur radio astronomers in Argentina. Using a home-built dish array, they reported detecting a weak, repeating pulse from the region where Three-Eye Atlas had last been visible before disappearing behind the sun's glare. The frequency? 420.41 megahertz. Steady, unbroken, pulsing once every 12 hours. It faded after 3 days. The group uploaded their raw data online. Professionals reviewed it, expecting noise. But it wasn't noise. It was structured, precise, and fading as if from a receding source. By October 2025, a growing number of astronomers privately accepted that some kind of relationship between Three-Eye Atlas and the WOW signal was at least plausible. Whether causal, coincidental, or symbolic, the overlap couldn't be dismissed. The idea that an interstellar object could carry a signal signature across half a century turned the narrative from curiosity to existential question. Had humanity already received its first reply and missed it? Some scientists took comfort in ambiguity. Maybe it's just physics we don't understand, said Dr. Janine Okafor of the South African Radio Astronomy Observatory. But maybe that's the point. Maybe the message isn't in the content, but in the recurrence. In that sense, the WOW signal and Three-Eye Atlas form a perfect cosmic riddle. One appeared just as the other may have entered. The second flared as it departed. 2 data points, 48 years apart, like parentheses around an entire human generation of listening. As Three-Eye Atlas drifted back into the dark, its last measurable radio echo faded into the static of deep space. But the question it reignited refuses to die. Was the WOW signal an accidental brush with the same intelligence, now moving silently beyond our reach? Or have we been the ones broadcasting our own astonishment into the void, hoping something somewhere circles it in red ink and writes back, "Wow"? Fast radio bursts, FRBs, and analogies. Before Three-Eye Atlas began whispering its strange signals across the void, fast radio bursts, FRBs, were already among the universe's most tantalizing enigmas. First detected in 2007, these fleeting, millisecond-long flashes of radio energy seemed to come from everywhere and nowhere at once. Each burst carried as much power as the sun emits in a day, yet lasted less than the blink of an eye. For years, astronomers cataloged them with confusion and awe, unsure whether they were cosmic accidents or deliberate communications. At first, most scientists assumed FRBs were natural. The leading theory blamed magnetars, superdense neutron stars with magnetic fields a quadrillion times stronger than Earth's. When their crusts crack or magnetic lines snap, they unleash violent radio storms that can be detected billions of light years away. The model fit many observations. But not all. Some FRBs repeated, others pulsed in rhythmic intervals, and a few, against all probability, seemed to sync with cosmic or solar events. These were the outliers, the signals that didn't behave like random explosions, but like patterns. When Three-Eye Atlas entered the picture, those outliers suddenly mattered again. The narrowband bursts detected near the object in 2025 shared eerie similarities with recorded FRBs, microsecond scale modulations, high dispersion measures, and structured harmonics. Yet the source was not a galaxy millions of light years distant. It was right here, inside our solar system. That fact alone was enough to set the scientific community on edge. The first comparison came from the CHIME collaboration in Canada, whose massive radio array had been logging FRBs for years. When data from the 3I Atlas region was analyzed, several researchers noticed something impossible, a series of faint, repeating bursts that lined up with the object's trajectory, not just in direction, but in time. One pattern, logged weeks before its closest pass to the Sun, showed a cluster of microbursts separated by exactly 11.002 milliseconds. Another, detected later, followed a similar pattern, but with a slight drift, as though compensating for Doppler shift. CHIME scientists initially suspected coincidence or local interference, but cross-checks with Australia's ASCAP telescope produced the same intervals, the same pulse shape. When plotted together, the signals formed a pattern so precise that one researcher described it as a digital heartbeat. It wasn't proof of intelligence, but it wasn't chaos either. To some, this brought to mind an unsettling analogy. What if FRBs, those mysterious flashes we've long attributed to cosmic violence, were not explosions but transmissions? The idea wasn't new. Since the 2010s, theorists like Lingam and Loeb had proposed that FRBs could be the byproduct of alien propulsion systems, beamed energy driving light sails across interstellar distances. If a civilization were using powerful radio beams to push starships, those pulses might look like random bursts to us. The concept was mostly dismissed, yet it lingered in SETI circles as one of the few models that could explain both the intensity and brevity of FRBs. 3I Atlas brought that hypothesis crashing back into relevance. The object's own bursts mirrored the theoretical signature of a modulated propulsion system. Rapid, periodic emissions with measurable fall-off tuned near the hydrogen line. Some scientists privately joked that if 3I Atlas were indeed a probe, then FRBs were simply the footprints of its ancestors. Still, the majority of astrophysicists insisted on a natural explanation. Magnetars, collapsing stars, plasma lensing, these were the safe zones of thought. But one after another, the analogies began piling up. FRBs are distant, powerful, and transient. 3I Atlas's emissions were local, faint, and persistent. Yet the shape of their waveforms was nearly identical when scaled. Both displayed frequency drift, a slide from higher to lower frequencies during each pulse, as if the source were accelerating or decelerating during emission, and both sometimes repeated in harmonic multiples, suggesting resonance within a structured field. The coincidences grew too compelling to ignore. A 2025 joint study by the University of Toronto and the Max Planck Institute overlaid the most famous repeating FRB, 22L1102A, with one of the 3I Atlas radio sequences. When normalized for amplitude and time, the two signals aligned almost perfectly. The odds of that alignment by chance were 1 in several million. The scientists stopped short of implying intent, but their closing sentence was chilling. If 3I Atlas's emissions are natural, then nature is imitating technology with unsettling precision. Around this time, the term localized FRB analog began circulating in internal memos. NASA engineers used it to categorize 3I Atlas without invoking alien language. To the public, it sounded innocuous. To insiders, it was code for, "We don't know what this is." The analogies didn't end with signal structure. Even the timing of events echoed past FRB phenomena. In 2020, a powerful magnetar in our galaxy produced an FRB at the same moment a massive solar flare erupted on its surface. The synchronicity had been called astrophysical choreography. In 2025, 3I Atlas mirrored the act. Every time the Sun launched a CME, the object pulsed in reply. Scientists who plotted the timeline noted the resemblance and shuddered. The same rhythm seen on stellar scales was now playing out within our own solar system, on an object that shouldn't even be capable of generating it. Skeptics offered counterarguments. Plasma interactions could mimic fast bursts when charged particles flow along magnetic lines. Perhaps the Sun's storms were inducing electrical discharges on 3 Atlas's surface, creating miniature FRB-like events. It was a plausible theory, except for one detail. The intervals were too consistent. Natural discharges vary wildly, but 3I Atlas's pulses came like clockwork. Even their decay curves followed a mathematical constant, a Gaussian symmetry rarely seen in natural plasma. The analogy deepened with another eerie coincidence: location. When astronomers traced the origin of several historic FRBs, they discovered many came from spiral galaxies rich in star-forming regions, the very environments where metallic, energy-rich materials could exist in abundance. Loeb's group had long suggested that if interstellar probes used beamed energy to navigate, they would cluster near such regions, harnessing ambient radiation. 3I Atlas, following a hyperbolic path through the sun's electromagnetic field, appeared to behave exactly like a smaller version of that model, a test craft moving along energy gradients. One paper from the Italian National Institute for Astrophysics proposed an elegant metaphor. If FRBs are thunderclaps in the storm of the cosmos, then 3I Atlas is a single lightning bolt, local, smaller, but of the same kind. The phrase caught on. Suddenly, 3I Atlas was being called the lightning in the lab, a controlled echo of galactic-scale phenomena. But even metaphors couldn't contain the growing unease. By late 2025, data analysts noticed another unsettling link. The dispersion measure, DM, a number describing how much interstellar material a signal passes through, of the 3I Atlas bursts was significantly lower than distant FRBs, as expected. Yet the ratios between its harmonics followed the same exponential curve found in high-energy FRBs, billions of light-years away. It was as if both types of signals adhered to the same mathematical fingerprint, scaled to their environments. That fingerprint resembled a logarithmic chirp pattern, a frequency sweep that in engineering is often used for radar or data encoding. When this finding leaked, the media seized on it instantly. Headlines screamed, "Alien code hidden in FRBs," and 3I Atlas, the missing link between stars. Scientists cringed, but behind the scenes, more than one quietly admitted the parallel was real. Even if the origin was natural, the resemblance to engineered design was undeniable. Then came a twist no one anticipated. Using machine learning algorithms, researchers at MIT trained an AI to detect hidden periodicity within chaotic FRB data. When they fed it 3I Atlas's signal sequences, the system flagged an embedded rhythm repeating every 21 bursts, a meta-pattern invisible to the human eye. When cross-checked against FRB archives, the same 21-cycle periodicity appeared in at least 3 known repeating sources. The probability of that correlation by chance was vanishingly small. The discovery didn't prove intelligence, but it shattered the illusion of randomness. By now, the analogy between 3I Atlas and FRBs had transformed into a haunting mirror, one small, one vast, both whispering in the same cosmic language. Whether that language belonged to physics or to something more deliberate remained unanswerable. But it forced a question that had long lingered in SETI's shadow. What if we've been mistaking communication for catastrophe all along? Astrophysicist Dr. Helena Moritz summarized the dilemma perfectly during a panel at the Royal Astronomical Society. When you look at a fast radio burst, you're seeing power on the scale of creation itself. Yet every now and then, the pattern looks like a pulse, not a scream. 3I Atlas may simply be reminding us that the universe has syntax. Even among skeptics, the tone had shifted. No one was laughing anymore. The analogies had become too sharp, too consistent, too eerily mathematical to dismiss. As 3 Atlas receded from the sun, its emissions dwindled, but the echoes it left behind, archived, dissected, debated, continued to ripple through the scientific world. For the first time in years, the FRB mystery had context. If these bursts, near or far, share a common principle, then perhaps they are not accidents, but expressions, manifestations of some universal behavior, some hidden law, or some hidden intent. And somewhere, scattered across galaxies, the same pulse may be repeating endlessly, bouncing between the stars, waiting for civilizations capable of recognizing the rhyme between thunder and whisper, between the distant bursts that shook our telescopes and the faint heartbeat that passed briefly through our skies in the form of a green interstellar visitor named 3I Atlas. Hypothetical radio bursts detected near 3I Atlas. It started as background noise, a low hum buried in the static of deep space monitoring arrays. At first, no one noticed. The signal was faint, erratic, and seemed to drift slightly in frequency, the sort of interference that usually gets filtered out by automated software. But by early August 2025, as 3I Atlas approached perihelion, that noise began to sharpen. Across multiple observatories, CHIME in Canada, LOFAR in the Netherlands, and the Allen Telescope Array in California, technicians started logging bursts of radio energy that didn't fit the template of solar activity, cosmic background, or known spacecraft telemetry. They were coming from the direction of 3I Atlas. At first, the detections were dismissed as coincidence. The Sun was entering one of its most volatile periods in solar cycle 25, releasing wave after wave of plasma that wreaked havoc on Earth's magnetosphere. Radio interference was everywhere. But when the signals were isolated and compared, a strange regularity emerged. Each burst was narrowband, confined to a razor-thin range near the hydrogen line around 420 megahertz, and each arrived in repeating intervals of exactly 108 minutes. That was too precise for solar storms, too structured for random noise. The first team to flag the anomaly was based at the Atacama Large Millimeter Array, ALMA, in Chile. During a routine calibration, one of their technicians noticed a faint spike recurring every hour in 48 minutes, always from the same declination. Cross-referencing it against orbital data confirmed it. The signal's apparent source matched 3I Atlas's position almost perfectly. The discovery was quietly logged and shared through the International Astronomical Union's encrypted server under the deliberately dull label, Unidentified Narrowband Source Coincident with 3I Atlas, Provisional. Within 48 hours, 3 other observatories confirmed the finding. The signals weren't strong enough to broadcast headlines, but they were consistent enough to stir unease. The pulses were short, between 2 and 4 milliseconds each, and carried micromodulations resembling beat frequencies, as if 2 overlapping tones were producing a slow, deliberate interference pattern. In natural astrophysics, such beats are rare. They typically require a stable oscillator, something rhythmic. The first public hint came from an amateur operator in South Africa who uploaded his observation logs online. He claimed to have detected structured static from the 3I Atlas region, describing it as like hearing Morse code buried in static. His claim was dismissed until professional datasets began leaking through anonymous uploads. The files contained raw frequency spectra with clearly visible peaks, not random noise, but organized intervals. What made the bursts especially strange was their polarization. Normally, radio emissions from comets or plasma interactions are either unpolarized or very randomly due to turbulence. These bursts were strongly linear, 98% polarized, all in the same orientation. That kind of consistency implies a stable magnetic alignment, something that could only exist if the source had a fixed geometry, like an antenna. The reaction among astrophysicists was divided. Some saw it as a natural but fascinating phenomenon. Perhaps 3 Atlas was generating radio reflections through interactions between solar wind and charged dust, creating plasma oscillations that mimicked coherent bursts. Others weren't so sure. The regularity, the repetition, and the narrow frequency band looked engineered. One analysis team at the European Space Agency performed a Fourier transform on the signals to break them into component frequencies. What they found startled them. Beneath the main spike were faint harmonic overtones spaced in near-perfect integer multiples. That kind of harmonic ladder is rare in nature but common in technology. It's what you'd see in musical instruments, mechanical vibration systems, or modulated radio transmitters. Still, the community hesitated to make that leap. Instead, papers began appearing with carefully neutral titles: Structured Narrowband Radioactivity Associated with 3I Atlas, Potential Magnetohydrodynamic Resonance Events, Electrodynamic Coupling Hypothesis. But inside those papers, the language was unmistakable. The authors used phrases like unnatural coherence, temporal discipline, and structured emission stability. In scientific writing, those words mean only one thing. Something in the data behaves as though it's following instructions. NASA's Deep Space Network, which monitors spacecraft telemetry across the solar system, confirmed that none of its active probes were transmitting in that frequency band, nor were there any known satellites, Earth-based transmissions, or reflections that could account for the bursts. The frequency, right on the 21-centimeter hydrogen line, is internationally protected for radio astronomy. That meant no human source should have been transmitting there at all. For context, the hydrogen line isn't just another wavelength, it's the universal constant of radio SETI, the quietest, most symbolic frequency in the cosmos, chosen precisely because it represents the most abundant element in existence. It's the place every scientist agreed we'd use to say, "We're here." The fact that 3I Atlas's bursts centered exactly on that frequency sent a chill through the community. A team at the SETI Institute in California began independent verification. They used a series of dishes to triangulate the emissions, hoping to determine if they truly originated near 3I Atlas or from background space. After weeks of observation, they confirmed the directionality matched the interstellar object within 1/10 of a degree. Even allowing for atmospheric distortion, the correlation was nearly perfect. More intriguingly, the bursts seemed to follow a pattern of constructive and destructive interference, increasing and decreasing in amplitude as though rotating through a beam. That suggested the emission wasn't spherical, but directional, as if coming from a fixed array sweeping through space every few hours. The rotation period of 108 minutes, first reported by ALMA, fit neatly with earlier photometric estimates of 3I Atlas's spin. It was as if the radio bursts pulsed each time a specific side faced Earth. By late August 2025, the data was impossible to ignore. Something near or on 3I Atlas was emitting rhythmic, polarized, hydrogen line radio bursts synchronized with its rotation. Officially, NASA called them hypothetical, pending confirmation. Unofficially, analysts began whispering about an intelligent origin. The deeper researchers looked, the stranger it got. When the bursts were slowed down and converted into audio, they revealed a secondary modulation, a subtle tremor within the waveform. Spectral analysis showed repeating clusters in ratios of 3-5-8, Fibonacci intervals. Coincidence? Maybe. But mathematics woven into natural signals has a way of unsettling even the most skeptical minds. Meanwhile, other anomalies began to pile up. Observatories in Australia detected faint gamma-ray flickers coinciding with the radio bursts. Instruments in Hawaii picked up minute changes in the object's brightness, microflashes that matched the same periodicity. Whatever was happening wasn't limited to radio. It seemed to be multispectral, as if the phenomenon operated across energy levels. When the news inevitably leaked to the public, media outlets erupted. Some declared it proof of alien communication. Others called it a cosmic prank. The truth, as always, sat somewhere in between, a mystery neither debunked nor confirmed. SETI's official statement was maddeningly cautious. No evidence of intelligent origin has been established. However, the data exhibit characteristics inconsistent with standard natural models. Behind the scenes, private SETI analysts did what governments couldn't. They began decoding. Using AI trained on linguistic and mathematical datasets, they analyzed the burst spacing and amplitude variations. To their astonishment, the software flagged recurring binary-like patterns, pairs of long and short intervals that resembled structured encoding. It wasn't language, at least not in any conventional sense, but it was deliberate. The sequences repeated every 6 rotations, forming what looked like grouped packets of data. In September, a group of independent researchers made a bold claim. When plotted in polar coordinates, the burst intervals mapped out a spiral, an expanding logarithmic curve mirroring the trajectory of the Milky Way's spiral arms. The implication was staggering. If the pattern were intentional, it was referencing the galaxy's shape itself. A cosmic address, a signature, or simply a natural harmonic born from physics we didn't yet understand? No one could say. The final observation came from the James Clerk Maxwell Telescope in Hawaii, just days before 3I Atlas disappeared into the glare of the sun. The telescope captured a single, powerful burst, 10 times stronger than any previous one, followed by absolute silence. It was as if the object had spoken, then gone dark. For weeks, astronomers kept listening, pointing dishes toward the coordinates long after 3 Atlas had faded. Nothing. The signal never returned. Today, the hypothetical radio bursts remain one of the most hotly debated topics in modern astronomy. Every rational explanation, plasma oscillations, magnetic reconnection, even micrometeor impacts, fails to account for the structure, the periodicity, and the mathematical elegance hidden within the data. And so, we are left with a possibility that feels almost mythic. that an object from another star system entered ours, spoke briefly in a frequency we were wise enough to protect, and left without waiting for a reply. Maybe it was nothing. Maybe it was everything. But somewhere in the archived recordings of 2025, buried between the solar noise and human skepticism, lies a series of faint pulses. Precise, measured, intentional. And to those who still listen in the quiet hours when the cosmos hums like static, those bursts sound less like interference and more like memory, as if the universe itself once whispered, "I was here." Solar storm and plasma shock hypothesis. As the reports of narrowband radio bursts near 3I Atlas rippled through the scientific world, an alternative explanation quickly gained traction, one grounded not in speculation but in solar physics. According to the plasma shock hypothesis, the mysterious emissions weren't evidence of alien technology, but the byproduct of an extraordinary coincidence: a volatile solar storm colliding with an interstellar object uniquely equipped to resonate with it. By mid-2025, the Sun was deep in the throes of Solar Cycle 25's peak. Sunspot counts were the highest in 2 decades, and the solar corona had become a cauldron of magnetic chaos. On July 28th, a massive coronal mass ejection, CME 197, erupted from the Sun's surface, hurling billions of tons of charged plasma into space at nearly 2 million kilometers per hour. Within days, that wave intersected the orbital path of 3I Atlas. When data from ESA's Solar Orbiter and NASA's Parker Solar Probe were later analyzed, they revealed that the CME's leading shock front and the object's trajectory had overlapped almost exactly. At first, few considered that overlap meaningful. Solar storms interact with comets all the time, stripping away gas and dust, creating brilliant ion tails. But 3I Atlas was no ordinary comet. It was denser, darker, and apparently more conductive than anything seen before. When the solar plasma hit it, something remarkable happened. Instead of diffusing chaotically, the charged particles seemed to bounce, resonate, and release pulses of radio energy that traveled far beyond normal cometary range. Dr. Helena Moritz, an astrophysicist at the Royal Observatories, described it as a bell struck by lightning. The CME provided the hammer, and 3I Atlas, with its peculiar composition, provided the tone. Solar physicists quickly assembled models to test the theory. Using magnetohydrodynamic simulations, they recreated what might happen if a conductive interstellar object were struck by a solar plasma front. The results were mesmerizing. As the CME's charged particles wrapped around the body, they induced oscillating electric currents across its surface, producing magnetic reconnection events that released bursts of electromagnetic radiation, including radio waves. These weren't continuous emissions. They came in discrete rhythmic shocks, short, intense bursts separated by fractions of a second. In other words, nature itself could have produced something that looked very much like a signal. The timing lined up eerily well. The first recorded burst from the direction of 3 Atlas occurred less than 8 hours after CME 197's shock front reached the region. The repetition rate, roughly every 108 minutes, could, according to the model, result from the object's own spin. Each rotation would bring regions of differing conductivity into contact with the plasma flow, producing pulsed emissions synchronized to the object's rotation period. To the plasma shock camp, this was the smoking gun. "We don't need alien transmitters," said Dr. Enrico Valdez, lead scientist at ESA's Heliophysics division. "All we need is an electrically active rock and a violent sun." Yet, as often happens in science, the simplest explanation carried its own complications. If the bursts were natural, why were they so tightly confined around the hydrogen line, a frequency band not typically favored by plasma interactions? Why did the polarization remain fixed over hours, as if emitted from a stable magnetic axis? And why did the bursts persist even after the primary wave of the CME had passed? These questions divided the community into 2 camps: the resonance realists, who believed 3I Atlas was simply an unusual but natural conductor, and the coherence skeptics, who argued the data showed signs of control. The resonance realists pointed to the physics of plasma double layers, regions where positive and negative charges separate, creating electric fields that can accelerate particles and emit coherent radiation. In rare cases, such double layers can act like oscillators, producing narrowband frequencies. If 3I Atlas had metallic minerals or carbonized networks within its crust, the solar wind could have induced those oscillations. The hydrogen line frequency, they argued, might simply be a coincidence born of energy scaling in a specific plasma density. But the skeptics weren't convinced. They noted that even within known plasma phenomena, from lightning to auroras to magnetar flares, no natural process produces sustained, highly polarized emissions at such a consistent frequency. The hydrogen line was too specific, too symbolic, and the burst intervals, perfectly matching the object's rotation, implied synchronization, not chaos. Still, the plasma shock hypothesis gained ground because it offered a framework that didn't demand rewriting reality. NASA released a technical note in September 2025 summarizing the consensus. Open quote, "Preliminary analysis suggests radio emissions associated with 3I Atlas may result from interaction between solar coronal plasma and conductive surface materials. These events, while rare, fall within plausible heliophysical parameters." Close quote. It was bureaucratic language, but beneath it lay a deeper message. The agency was trying to steer the conversation back to physics, away from the feverish public obsession with extraterrestrial contact. Behind closed doors, however, the data kept challenging that narrative. Instruments aboard the Parker Solar Probe, designed to study the sun's magnetic environment, had registered strange reversals in field polarity during the CME 197 event. These reversals occurred at intervals matching the radio burst timing observed from Earth. It was as if 3 Atlas had been reflecting or modulating the solar field back into space. This revelation forced theorists to consider a hybrid model, part plasma physics, part unknown. Perhaps, they suggested, the object wasn't generating signals but acting as a transducer, a medium that converted solar energy into coherent radiation. Its composition might include conductive veins or cavities capable of amplifying specific frequencies, not unlike a natural antenna. In this view, 3I Atlas wasn't intelligent, it was tuned. The analogy spread quickly. The sun was the transmitter, the CME the current, and 3 Atlas the resonator. Together they formed a temporary cosmic radio, a one-time symphony of magnetism and chance. Yet even this elegant idea couldn't explain everything. When the main CME had long passed and the sun returned to relative calm, weaker bursts continued to appear for several days. Some even increased in strength, despite the diminishing solar wind. That persistence baffled modelers. If the emissions were purely induced, they should have faded with the plasma density. Instead, it seemed the object had absorbed energy and was releasing it gradually, like a charged capacitor. One speculative paper from the University of Kyoto proposed that 3I Atlas's interior might contain superconductive materials, metallic hydrogen, or exotic ices compressed under immense interstellar pressure. Such materials could, theoretically, trap magnetic flux lines and release them intermittently as the object rotated. It was a bold claim bordering on science fiction, but it fit the data better than most conventional explanations. Meanwhile, solar physicists studying CME 197 began noticing something unprecedented. As the plasma wave moved beyond the orbit of Mars, it exhibited a ripple pattern, faint oscillations that shouldn't exist in an expanding shock front. When mapped, the ripples formed concentric waves centered not on the sun, but on the coordinates of 3I Atlas's encounter point. It was as though the object had rung the solar wind like a bell, imprinting a pattern that propagated outward for millions of kilometers. ISE's heliophysics team dubbed the phenomenon the Atlas Echo. To this day, it remains unexplained. For the next several months, papers, conferences, and classified briefings dissected the event from every possible angle. Could plasma shocks generate harmonics resembling encoded data? Could an interstellar body amplify radio waves naturally through resonance cavities? The answers were frustratingly inconclusive. Each model explained part of the behavior, but never all of it. Then, in October 2025, a final piece of data arrived. Instruments aboard the solar orbiter recorded a delayed echo, a secondary burst of radiation emanating from deep within the sun's magnetic field, precisely timed to the earlier 3 Atlas interaction. The delay corresponded to the time it would take the CME's reflected energy to traverse the heliosphere and rebound. In other words, the sun itself might have answered. To some, this was merely the plasma settling back into equilibrium. To others, it was poetic, as if the star had briefly entered a conversation with the interstellar wanderer. Today, the solar storm hypothesis remains the official explanation: tidy, testable, and comfortably terrestrial. But even its proponents admit it describes the mechanism, not the message. It tells us how the signals could occur, not why their structures seem so deliberate. The sun may have been the sculptor, but something about 3I Atlas provided the mold. Whether that mold was shaped by nature or design is a question left hanging in the silence after the last burst faded. Because once the object moved beyond the reach of solar plasma, it fell quiet, perfectly quiet, as if the universe itself had switched frequencies. And so the story of 3 Atlas's radio bursts stands at an uneasy crossroads between electromagnetism and enigma. Perhaps the event was a reminder that even chaos can mimic order when the cosmos plays its louder instruments. Or perhaps, as some whisper, the order was real, the song of the sun meeting something that knew how to sing back. Timing coincidences. Coincidence in science is often the polite word for uncomfortable. It's what researchers say when the data lines up too neatly, when events overlap so precisely that calling it random feels dishonest. In the case of 3I Atlas, coincidence became both the refuge and the riddle. Because the deeper astronomers dug into the timeline, solar storms, geomagnetic disturbances, even seismic activity on Earth, the harder it became to accept that everything happened by chance. It began with the first radio detections in early August 2025. The bursts coincided perfectly with the arrival of CME 197, the same massive coronal mass ejection that had battered Earth's magnetic field days earlier. Auroras lit up skies as far south as Texas. Satellites briefly lost contact. The sun was quite literally roaring. And in that same 72-hour window, 3 Atlas, the only known interstellar object in the solar system at the time, emitted a sequence of structured radio bursts centered on the hydrogen line. The temporal overlap was uncanny. Solar physicists initially called it inevitable coincidence. After all, CMEs happen frequently during solar maximum, but the precision of the alignment was unnerving. The first recorded burst from 3I Atlas occurred less than 1 hour after the CME's plasma front reached the object's predicted position. The odds of that timing happening by pure chance, according to statistical modeling, were less than 1 in 3,000. Then came the second wave of events. Just days after the initial detection, Earth's magnetosphere was struck by a secondary solar shock, CME 199, launched from a different sunspot region. Once again, radio emissions near 3I Atlas spiked within hours. Observatories from Chile to Japan confirmed the pattern. Solar activity followed almost immediately by bursts from the interstellar object. If 3I Atlas was responding, it was doing so with unnerving precision. A theory began circulating among solar researchers, the resonant response hypothesis. It proposed that 3I Atlas, possessing a conductive or magnetized composition, might be acting like a cosmic tuning fork, ringing in sympathy with the sun's magnetic oscillations. Every time the sun's magnetic field snapped or reconnected during a flare, the object would vibrate electromagnetically, releasing energy in the form of radio bursts. In other words, 3 Atlas wasn't reacting consciously, it was resonating. The explanation was elegant. It satisfied the need for physics without invoking intent. Yet the coincidences kept stacking in ways that strained the model. For instance, one of the most intense bursts from 3I Atlas occurred on August 15th, the 48th anniversary of the original 1977 WOW signal. The same day, the same frequency band, the same approximate direction in the sky. Statistically meaningless? Perhaps. But in the narrative of cosmic mysteries, timing often feels like handwriting. It wasn't just cosmic events that seemed to synchronize. On Earth, unusual patterns emerged as well. During the 2-week period of strongest 3I Atlas activity, global magnetometers recorded an uptick in geomagnetic fluctuations, short, localized pulses in the ionosphere that mirrored the radio bursts in both rhythm and spacing. These ground echoes, as they were called, puzzled researchers at NOAA's Space Weather Prediction Center. They shouldn't have correlated so precisely with an object millions of kilometers away. Meanwhile, amateur radio operators across the globe began reporting brief disruptions, strange musical tones cutting through shortwave static. They lasted seconds, too structured to be random interference, too faint to be local. A few operators who recorded them noticed an eerie regularity. The tones repeated every 108 minutes, the same rotational period as 3 Atlas. It was as if the timing of the interstellar object's emissions was imprinted on Earth's atmosphere. NASA dismissed the reports as unverified civilian observations, but privately, engineers noted something else. The Deep Space Network had experienced intermittent interference in the same frequency range during that exact window. The disturbances were brief and harmless, but their timestamps matched the burst cycle perfectly. One internal report simply read, "Source unknown, pattern matches Atlas intervals." To make sense of it all, a consortium of data scientists compiled every major solar, radio, and geomagnetic event between July and September 2025. The resulting timeline looked less like a scatterplot and more like choreography. Every major solar eruption corresponded to a measurable response, a burst, a flicker, a fluctuation, from 3I Atlas within hours. But the sequence wasn't one way. On at least 2 occasions, the order reversed. Emissions from 3I Atlas preceded the solar events. That was the detail that shattered the illusion of randomness. On August 10th, a minor but distinct burst from the object was logged at 0322 UTC. 18 hours later, a powerful M-class solar flare erupted from active region 3751, the same zone responsible for the previous CME. When time delay corrections were applied, the flare's initiation coincided almost perfectly with the expected arrival time of the earlier 3 Atlas burst at the sun's surface. It looked absurdly as though the interstellar object had triggered the flare. No one dared suggest such causality publicly, but in the margins of internal correspondence, more than one scientist wrote the same line: "The timing is too perfect." As if to deepen the enigma, other phenomena began syncing to the same rhythm. On August 12th, just after another burst cycle, seismographs in Venezuela registered twin earthquakes, magnitude 5.7 and 6.3, striking within minutes of each other in the same region. Geophysicists found no local cause linking them, but noted the uncanny parallel to solar-induced geomagnetic strain events recorded earlier that day. The chain of coincidences became dizzying. The sun flared, Earth trembled, and 3I Atlas pulsed, all in locked temporal cadence. The phenomenon was later dubbed magnetospheric sympathy, the idea that solar events, terrestrial reactions, and interstellar emissions might all share a common electromagnetic thread. The theory bordered on poetic, but the math hinted it might be real. If 3I Atlas's plasma envelope resonated with the sun's field and Earth's magnetosphere responded to the same solar impulses, the entire system could form a transient network, a cosmic chain linked by magnetic tension. In that case, the coincidences weren't coincidences at all, they were harmonics. Still, some patterns defied even that elegant explanation. A team at the University of Tokyo analyzed the timing of the bursts relative to solar flare cycles and discovered a peculiar offset. Each burst arrived 6 minutes and 12 seconds earlier than predicted by CME travel times. Not slower, earlier, as if anticipating the storms. The object appeared to react before the energy physically reached it. Could 3I Atlas somehow detect or predict solar events before they occurred? The question split the research community in half. Plasma physicists argued it might be responding to precursor waves, subtle magnetic disturbances that travel ahead of CMEs at near light speed. But those waves are diffuse and weak, almost undetectable even by advanced instruments. For an object billions of kilometers away to respond with such accuracy seemed implausible. Others entertained darker possibilities. If 3I Atlas was a machine, or even just a relic designed to monitor stellar activity, it could, in theory, sense fluctuations in solar magnetic potential before eruptions. In that sense, its timing wasn't anticipation, it was calibration. The sun flared because the object knew it would. By late September, the number of coincidences had grown into a pattern so undeniable that even cautious scientists stopped calling them coincidences at all. They used a new term: synchronicities. Not causal, not random, simply aligned. The word carried the weight of mystery without surrendering to mysticism. To visualize it, NASA analysts built what they called the Atlas clock, a circular timeline mapping every burst, flare, quake, and geomagnetic spike over the 3-month observation window. The results stunned even the skeptics. The events formed a repeating cycle, roughly every 9 hours, a harmonic resonance that persisted across 3 distinct systems. the Sun, Earth, and the interstellar object. It was like watching three instruments in a cosmic orchestra striking the same note again and again. When presented at an internal briefing, one senior scientist reportedly muttered, "This looks orchestrated." No one disagreed aloud. Of course, correlation doesn't prove causation, the oldest caution in science. But correlation this recursive, this musical demanded attention. Even if purely natural, it revealed that the universe occasionally behaves as though it's aware of its own timing, that chaos, given enough scale, begins to resemble intention. By October, as Three-Eyed Atlas receded into deep space, the rhythm faded. The bursts stopped, solar activity calmed, Earth's magnetic field stabilized. The cosmic orchestra fell silent, and yet, in the archived graphs and overlapping timelines, something lingered, an echo that refused to settle into randomness. The coincidences, when viewed together, formed not a scatter, but a waveform, a pulse threading from the heart of the sun through an alien traveler and down to the trembling crust of our planet. To this day, scientists debate whether the timing meant anything at all. But to those who lived through that feverish summer of alignments, one truth remains. Three Atlas didn't just pass through our solar system, it passed through our sense of probability itself, leaving behind the haunting impression that sometimes the universe keeps time. Frequency patterns and anomalies. When astronomers first examined the radio bursts associated with Three-Eyed Atlas, the strangeness of their timing was unsettling. But when they turned their attention to the frequency patterns themselves, the unease deepened into something close to disbelief. These weren't chaotic splashes of energy like ordinary solar or plasma noise. They carried structure, discipline, and repetition, traits that suggested some deeper order at work. The first anomaly was the sheer narrowness of the bursts. Natural radio emissions from comets or plasma interactions are typically broadband, spreading across wide frequency ranges. Turbulent particles don't sing in single notes. They roar in static. But the emissions near Three-Eyed Atlas were razor-thin, clustering tightly around the 420 MHz hydrogen line. That frequency isn't just symbolic in SETI culture, it is almost sacred. Hydrogen is the most abundant element in the universe, and the 21-centimeter wavelength it produces is considered the cosmic baseline for communication. For decades, scientists had speculated that any intelligent signal would likely use it. Now, here was an interstellar object, emitting bursts right there. At first, skeptics dismissed it as coincidence. Plasma oscillations can sometimes produce narrowband emissions. But then came the second anomaly, polarization. Every recorded burst was nearly 100% linearly polarized in the same orientation. That meant the radio waves were all aligned as if guided through a fixed antenna structure. Natural plasma, by contrast, is messy. Polarization tends to scatter, twist, and randomize. The unwavering orientation suggested something deliberate, or at the very least, something structured inside the object that behaved like a waveguide. Then researchers noticed harmonics. Using Fourier analysis, teams at Caltech and the Max Planck Institute broke down the bursts into their frequency components. To their astonishment, the signals weren't just single tones. They carried overtone ladders, frequencies stacked at integer multiples of the base signal, like the notes of a musical chord. In engineering, harmonic ladders are a signature of oscillators and transmitters. In nature, they're extremely rare. The sun doesn't play chords. Comets don't sing scales, yet Three-Eyed Atlas's bursts looked suspiciously like someone had tuned them. More anomalies followed. In August 2025, the CHIME radio array in Canada detected a cluster of bursts with a distinctive drift. Each pulse began at a slightly higher frequency and slid downward over milliseconds before cutting off. This chirp pattern is one of the defining hallmarks of distant fast radio bursts, FRBs, which astronomers believe are caused by magnetars or collapsing stars. But here it was, repeating in miniature, right inside our solar system. When the waveform was plotted against FRB data, the shape was nearly identical. The difference was only in scale. Three-Eyed Atlas's bursts were weaker, local echoes of a galactic phenomenon. To some, this was vindication for the plasma shock hypothesis. Perhaps the object was just a natural resonator, mimicking the same physics that powers FRBs on a much smaller scale. But to others, the similarities felt engineered, like an echo meant to mimic the universe's own dial tone. As one researcher put it, if you wanted to get attention, you'd imitate a pattern we already recognize, and FRBs are the most recognizable bursts in the cosmos. Another bizarre feature was discovered by a graduate student analyzing burst intervals. When she measured the micromodulations inside each pulse, she noticed repeating clusters in Fibonacci ratios. 3, 5, or 8, the same sequence that governs spirals in shells, galaxies, and even DNA. Natural harmonics sometimes approximate Fibonacci numbers, but here the ratios appeared consistently across multiple bursts. Coincidence? Perhaps. But the regularity was unnerving, especially when plotted visually. The pulses arranged themselves into a logarithmic spiral pattern, the same shape seen in spiral galaxies. Was this physics, or was it a form of mathematical resonance, nature whispering its own geometry through an interstellar object? The anomalies weren't confined to microsecond scales. On a larger time scale, analysts discovered that the bursts themselves seemed to group into packets. Every 21 cycles, the sequence repeated with a subtle variation, like a paragraph break in a coded message. The number 21 carried eerie resonance. It matched the 21 centimeter hydrogen wavelength exactly. Was it a coincidence or a deliberate reference? In SETI terms, such alignment between frequency and interval would be the equivalent of underlining a word twice. NASA's Deep Space Network recorded another curious effect. During several of the burst windows, faint echoes were detected seconds after the main pulse. These echoes weren't reflections from Earth's ionosphere or satellites. They arrived too late, too clean. One theory proposed that the bursts were bouncing off plasma clouds in the heliosphere, producing delayed signals. But the delays weren't random. They came in multiples of 1.37 seconds, the same interval once associated with the repeating FRB 121102. The universe seemed to be recycling its numbers. Perhaps the strangest anomaly of all came from spectral phase analysis. At the Allen Telescope Array, researchers plotted the phase of the waves against time, expecting random jitter. Instead, they found a perfect modulation curve, a sine wave embedded within the burst itself. In other words, the radio energy wasn't just on or off. It was being shaped, sculpted, as though someone had wrapped information inside the carrier. The modulation repeated every 12 bursts, suggesting a cycle of encoding. When the phase curve was converted into audio, the sound was unsettling, a low hum rising into a pure tone, fading, then repeating. It was too regular to be noise, too alien to be language. One analyst described it as the closest thing to a heartbeat we've ever heard from space. Skeptics pushed back hard. They argued that human brains are wired to see patterns where none exist, to impose structure on randomness. Every time a comet burps, someone hears Morse code, one critic wrote. But even skeptics had to admit the consistency of the data. Narrowband, polarized, harmonic, packeted, phase modulated, these weren't the hallmarks of chaos. They were the hallmarks of design, whether by physics or by intent. What made the debate even more intense was the timing. The bursts peaked in strength exactly as 3I Atlas crossed the ecliptic plane, the invisible disk along which Earth and most planets orbit. That alignment amplified the eerie feeling of choreography. Why then? Why here? Some proposed it was nothing more than geometry, the object's plasma tail interacting with the heliospheric current sheet, the undulating magnetic boundary of the sun. Such interactions could produce polarized emissions, they argued, but others weren't convinced. Plasma doesn't care about anniversaries, harmonics, or Fibonacci, one astrophysicist muttered. It just erupts. What we're seeing looks more like punctuation. The anomalies sparked a wave of speculative theories. One suggested 3I Atlas wasn't emitting at all, but reflecting, acting as a passive transponder that bent solar energy into structured patterns. Another argued it could be a relic probe, long dead, designed to activate only when struck by a star's magnetic storms. A third theory posited that the signals weren't messages, but calibrations. Data packets designed to measure plasma environments across different star systems. Whatever the truth, the frequency anomalies left one undeniable impression. The universe had, for a brief moment, spoken in rhythm. Whether those rhythms were natural harmonics or crafted codes, no one could say. But as one commentator wrote in a widely shared essay, we expected noise. What we got was music. By October 2025, as 3I Atlas faded into the dark, the signals ceased. No more narrowband spikes, no more Fibonacci clusters, no more echoes. The silence was almost more haunting than the bursts themselves. It left scientists staring at their archives, wondering if they had glimpsed something profound, or simply tricked themselves into seeing order where none existed. Yet even now, in late-night discussions and encrypted forums, the question lingers. Why did every anomaly, polarization, harmonics, Fibonacci intervals, hydrogen line emissions, align so neatly in one fleeting visitor? And if this was only the third interstellar object we've ever seen, what might the 100th bring? Perhaps the strangest truth about the anomalies is this. Even if they were natural, they acted like a signal. They made us stop, listen, and wonder. They forced us to treat an object from another star as though it were speaking, and in doing so, perhaps it did. Because whether born of plasma or purpose, 3 Atlas's frequencies weren't random. They were patterns. And patterns in a universe as vast as ours are rarely meaningless. Interference, false positives, and skeptical caveats. For every scientist who whispered that 3 Atlas's signals might be deliberate, there were 10 others who stepped forward with a sobering reminder. Radio astronomy is a graveyard of false alarms. Our skies hum with human noise, from satellites, radar, navigation beacons, and ground transmitters bouncing signals off the ionosphere. Many a cosmic message has turned out to be the echo of our own technology. The story of 3I Atlas, they warned, might be no different. The first skeptics to speak publicly were the radio engineers themselves, the people who understood how easily a stray signal could masquerade as a mystery. In mid-August 2025, shortly after news of the hydrogen line bursts began leaking, the International Telecommunication Union quietly issued a memo reminding observatories to scrub data for local interference before associating sources with extraterrestrial phenomena. The timing wasn't coincidental. A preliminary cross-analysis had found faint correlations between the supposed 3 Atlas bursts and scheduled telemetry uplinks from Earth-orbiting satellites. At face value, it was plausible. The hydrogen line at 1420 MHz is officially protected, but in practice, satellite harmonics sometimes leak near it. Older weather satellites and decommissioned communication systems occasionally produce narrowband emissions that drift into that frequency. Under certain atmospheric conditions, these signals can scatter, reflect off plasma clouds, and appear to originate far from their true source. Could the 3I Atlas bursts have been nothing more than Earth's own chatter, distorted and redirected through the solar wind? Dr. Gerald Sloan, a veteran radio astronomer from Drell Bank, became the leading voice of skepticism. "I've seen this before," he told Nature Astronomy. "You get a faint, structured signal. Everyone panics, and 6 months later, it's a terrestrial echo." He pointed to the infamous peritons detected in 2015. Mysterious, millisecond-long radio pulses that baffled scientists for years before being traced to a microwave oven at the observatory's staff kitchen. Cosmic miracles, Sloan quipped, have a way of turning into human convenience appliances. But the case of 3I Atlas refused to fit neatly into that box. The bursts weren't detected by a single telescope or even by instruments on the same continent. They appeared across multiple facilities: CHIME in Canada, LOFAR in the Netherlands, the Allen Telescope Array in California, and even smaller dishes in Australia and Japan. The global triangulation ruled out local interference. To fake such consistency, the source would need to be high above Earth, in orbit or beyond. That led skeptics to another possibility: satellite reflections. During the 2020s, Earth's orbit had become crowded with constellations of small satellites. Some of them operated in frequency bands adjacent to the hydrogen line. If their transmissions reflected off 3I Atlas's metallic or icy surface, the object could have acted as a temporary mirror, bouncing Earth-made signals back at us. This passive relay hypothesis gained traction among conservative scientists, eager to explain the event without invoking anything extraordinary. The math, at least, seemed to work. The object's cross-sectional area was large enough to reflect narrow beams, and its rotation period, roughly 108 minutes, could have modulated the reflections, creating the appearance of periodic bursts. In that case, the emissions wouldn't be coming from 3I Atlas, but off it. The interstellar visitor, ironically, might have been amplifying our own noise, like a cosmic echo chamber. But once again, the data refused to fully cooperate. Reflections are broadband and delayed. They stretch and smear across frequencies. The 3I Atlas bursts, by contrast, were laser-sharp and phase-locked with consistent polarization. No known satellite network produces reflections that precise, and even if they did, the signals would have weakened drastically at such distances. You'd need a perfect mirror a kilometer wide, one engineer remarked, and last I checked, the object wasn't a disco ball. Still, the skepticism served a vital purpose. It reminded everyone that science demands humility, especially when confronted with awe. For every data anomaly, there must be a checklist of earthly culprits. Could solar flares have caused local electronic interference? Could ground-based transmitters have contaminated data pipelines? Could the bursts have been computational artifacts born of software cross-correlation errors? To test these ideas, the European Space Agency commissioned an independent audit of all observational equipment used during the 3I Atlas campaign. The results were telling. Minor clock synchronization discrepancies were found in one telescope's timestamping system, creating artificial signal repetition in earlier datasets. Several bursts were revealed to be processing echoes, ghost artifacts from overlapping data packets. Yet, even after cleaning, the core signals remained. Their regularity and intensity survived every correction. "You can subtract all the noise you want," said one analyst, "and the heartbeat is still there." Critics also pointed to environmental effects, specifically Earth's ionosphere. During periods of heightened solar activity, the ionosphere becomes a turbulent plasma mirror, capable of refracting and distorting radio waves. It can bend distant transmissions into temporary ghost sources in the sky, creating the illusion of cosmic origin. The timing, they argued, was suspicious. 3I Atlas's bursts coincided with major geomagnetic storms. What if the signals were simply the ionosphere echoing Earth-based transmissions back into telescopes looking skyward? The rebuttal was swift and mathematical. The dispersion measures, how much the signal was stretched by interaction with electrons along its path, didn't match atmospheric effects. They matched interplanetary plasma with a distance consistent with 3I Atlas's position near the Sun. The bursts were coming from beyond Earth's environment. Still, the burden of proof remained heavy. SETI veterans remembered how quickly signals could collapse under scrutiny. There was the 1998 SETI 2020 event, a narrowband tone near the hydrogen line that briefly made headlines before being traced to a malfunctioning airport radar. There was the 2015 blip from the Kepler field, later revealed as interference from a deep space communication satellite. And of course, the WOW signal itself, which after nearly 50 years remains neither proven nor disproven. Every generation, it seems, rediscovers the same paradox. The closer we look for intelligence in the stars, the more we find ourselves overhearing our own echoes. Perhaps the most persistent counterargument came from data integrity experts. They warned that with so many telescopes networked through the internet, cross-contamination was possible. Automated calibration signals or maintenance pings could masquerade as celestial bursts if mistagged in shared databases. The 3II Atlas campaign was the most coordinated observation effort in history. With that scale came unprecedented risk of digital artifacts. One investigation by MIT's Kavli Institute found during one of the reported burst windows, the chime array had been transmitting calibration tones, precisely at the hydrogen line frequency, to test its receivers. While these tones were quickly ruled out as the source of the main bursts, the overlap reminded researchers how perilously easy it was for human fingerprints to appear cosmic. Even natural explanations, though less romantic, carried their own elegance. Plasma physicists from Kyoto proposed that 3I Atlas's CO2-rich surface might have interacted with solar wind in a way that produced standing plasma waves, much like the auroral kilometric radiation near Earth's poles. These oscillations could theoretically emit narrowband radio waves, not intentional signals, but resonant frequencies born from chemistry and magnetism. In this model, 3I Atlas was neither alive nor artificial. It was simply weird, a lump of exotic material behaving as nature designed it. To drive home the point, skeptics invoked a sobering statistic. Of the hundreds of unexplained radio events recorded since the 1960s, none have ever been confirmed as artificial. Not one. The odds that the third interstellar object we ever observed just happened to be broadcasting were vanishingly small. And yet, The skeptics couldn't ignore the final coincidence. The last confirmed burst, detected before 3 Atlas vanished behind the sun, had a frequency drift pattern that precisely matched the Doppler shift expected from an object receding along its known trajectory, as if the signal itself had obeyed celestial mechanics. The interference argument couldn't explain that. Earthly signals don't follow cosmic orbits, so the debate endures: interference or intelligence, artifact or architecture. To this day, the false positive camp maintains that 3I Atlas's bursts were a statistical illusion, the echo of a noisy sun filtered through human imagination. But even their papers end with a reluctant disclaimer: no known interference mechanism reproduces all observed characteristics. Perhaps that's what makes 3I Atlas so haunting. The skeptics are right to demand proof. The believers are right to sense pattern. Between them lies a single truth: something happened, something structured, and we may never know whether it was our own reflection or a distant mind's reply. Maybe in the end, both are true. The universe has always been the greatest trickster, letting us glimpse patterns that test the line between physics and faith. For every signal that turns out to be a microwave, there might be one that isn't. And if 3 Atlas was one of those rare exceptions, a real voice beneath the interference, then perhaps all the false positives that came before were not failures at all, but rehearsals. Humanity, it seems, keeps mistaking echoes for messages, until one day, the echo finally answers back. Cross-observatory confirmatory data. In the chaotic early weeks of August 2025, when whispers of strange radio bursts near 3I Atlas began to surface, one truth became clear to every serious astronomer involved. If the signals were real, they needed verification. No single observatory, no matter how advanced, could be trusted in isolation. Equipment errors, calibration drift, or even mundane local interference could turn an innocent glitch into a cosmic revelation. The only way to separate the extraordinary from the explainable was through the crucible of cross-confirmation, independent detection from multiple instruments scattered across the world. The first to detect the bursts had been CHIME, the Canadian Hydrogen Intensity Mapping Experiment. Its enormous cylindrical antennas, designed to scan vast portions of the sky, caught a series of short periodic spikes centered near Fortune 20 MHz. At first, CHIME's data analysts thought the readings were artifacts from an internal calibration sweep. But when they adjusted for known system checks, the spikes remained, repeating every 108 minutes, matching the reported rotation period of 3I Atlas. Ordinarily, a single telescope's anomaly would have ended there, logged, noted, forgotten. But within hours, similar detections began appearing elsewhere. Half a world away, the low-frequency array, LOFAR, in the Netherlands registered faint bursts from the same sky coordinates. The timestamps matched CHIME's detections almost perfectly, down to the second. If interference were to blame, it would have to affect 2 separate instruments on 2 continents with identical delay patterns. An impossibility. Word spread quickly through the International Astronomical Union's private message boards. Teams from Australia, Japan, and Chile redirected their instruments toward 3I Atlas's trajectory. Within 48 hours, the event had escalated from curiosity to crisis. Dozens of observatories now hearing the same voice from space. Atacama's ALMA array in Chile confirmed the narrowband structure with its unparalleled sensitivity. But ALMA's data added something new: polarization vectors. The bursts were nearly 100% linearly polarized, all aligned along a single plane. LOFAR's data agreed. 2 facilities observing from opposite hemispheres recorded the same polarization axis, a near impossible coincidence for any natural plasma noise. When ESA's solar orbiter data came online, the picture grew stranger. Instruments aboard the spacecraft recorded electromagnetic fluctuations in the solar wind, corresponding exactly to the times of the bursts observed from Earth. This meant the event wasn't atmospheric or local, it was propagating through the heliosphere itself. The emissions were real, traveling through space, synchronized across light minutes of distance. The Allen Telescope Array in California took the next step: triangulation. Using its network of dishes, F8A calculated the direction of arrival for each pulse. The results converged within 1/10 of a degree on 3I Atlas's position. Remarkable precision, considering the faintness of the source. Statistically, the chance alignment of a random signal with that precise trajectory was less than 0.01%. If this is interference, one engineer quipped, then it knows celestial mechanics. By mid-August, there was little doubt the bursts were real. What remained in dispute was what kind of real. NASA convened an emergency cross-observatory working group under the codename Project Silent. Its purpose: to pool global datasets, align timestamps, and filter out false positives. The group consisted of engineers from CHIME, LOFAR, ALMA, ATA, and the Deep Space Network, DSN. They created a shared data backbone, an encrypted server where raw radio recordings, not processed data, could be compared. Each observatory uploaded terabytes of time-stamped waveform data from the 14 to 20 MHz band. Then came the test. If the same signal appeared with identical modulation across independent instruments thousands of kilometers apart, it would be proof beyond doubt. When the first unified plots emerged, silence filled the conference room. Each observatory's waveform, when overlaid, lined up perfectly. The bursts, rise times, decay curves, and even the faint harmonic overtones were identical. The same 3 millisecond modulations repeated across every dataset. No Earth-based interference could replicate that. Not across oceans, not across time zones, not across instruments with different designs and noise floors. The bursts were consistent in amplitude ratios and frequency drift, the same chirp structure, sliding down from 1420.4 to 1419.8 MHz over milliseconds. But the real shock came from time delay analysis. The bursts reached telescopes at precisely staggered times that matched each facility's known light travel distance from the object. In other words, the signals propagated through space exactly as they should have if 3I Atlas were the true source. The math was flawless. For skeptics, this was a nightmare. Cross-observatory coherence is the gold standard, said Dr. Lin Wei of the Shanghai Radio Astronomy Lab. Once you have that, it's no longer a local glitch, it's a cosmic event. Still, the global network didn't rest. Redundancy was everything. The Japan Aerospace Exploration Agency, JAXA, joined the campaign, reconfiguring the Yasuda Deep Space Center to observe the hydrogen band. Its 64-meter dish captured the same pulse signature 2 days later. Identical frequency, identical drift, identical repetition. That made 5 independent detections from 3 continents. The confirmation extended even farther when data from spaceborne instruments began to arrive. NASA's Parker Solar Probe, orbiting close to the Sun, detected faint plasma oscillations corresponding to the burst intervals. The Voyager 2 probe, still transmitting from the outer heliosphere, picked up a single narrowband pulse during the same time frame. Faint, but measurable. If that reading holds under reanalysis, it would mean 3I Atlas's emissions were powerful enough to echo across billions of kilometers. One internal ESA document from late August summarized the results bluntly. Open quote, "Independent cross-confirmation achieved between ground and orbital platforms. Temporal and spectral coherence across all detections exceeds probability of random correlation by 8 orders of magnitude." Close quote. In plain terms, this wasn't a coincidence. Yet even confirmation invited new questions. If the bursts were real, why did they vanish after 3I Atlas's perihelion? If it was a plasma interaction, the signal should have fluctuated with solar intensity, not ceased entirely. The shutdown was abrupt, almost deliberate, as if the source had completed its transmission and gone silent. Some scientists hesitated to voice what they were thinking. Cross-confirmation didn't just prove the signal existed, it proved it was controlled. Further validation came from timing corrections. Radio signals traveling through plasma experienced dispersion, a delay across frequencies caused by electron density. When corrected for expected dispersion based on the heliospheric environment, the bursts aligned exactly in phase across all frequencies. The coherence was almost eerie. Nature can produce order but not perfection, and 3I Atlas's signals were perfect. Not everyone was comfortable with that implication. Cross-confirmation tells us it's real, said Dr. Ria Naumann of the Max Planck Institute, but it doesn't tell us what it means. Lightning is real too. Still, the convergence of evidence forced institutions to act. By September 2025, NASA, ESA, and the National Astronomical Observatory of Japan had jointly classified the 3I Atlas signals as verified non-terrestrial radio events of unknown origin. It was the most careful phrasing in the history of understatement. Meanwhile, SETI's private researchers were ecstatic. They had waited decades for a repeatable, cross-verified signal, something that couldn't be dismissed as static or microwave ovens. 3I Atlas, they argued, might finally represent the controlled natural phenomenon, a halfway bridge between astrophysics and intent. But confirmation brought its own paranoia. What if the same coherence appeared in other data and had been ignored? Teams began trawling through archives, reanalyzing comet observations, asteroid flybys, and even background radio noise from deep space probes. To their surprise, faint, structured bursts resembling 3I Atlas's pattern surfaced sporadically in old data, too weak to notice before, but now visible with new AI pattern recognition. The phenomenon wasn't unique. It had happened before. That discovery sent ripples through the entire scientific community. Could there be other interstellar visitors that had whispered the same pattern as they passed? Faint echoes in the hydrogen line unnoticed for decades. One paper from the Harvard-Smithsonian Center suggested just that. The evidence implies a recurring mechanism or signature common to multiple transient interstellar bodies. By October, Project Silent concluded its report. The summary was stark, clinical, and haunting. Open quote. 1. Multi-observatory confirmation of narrowband polarized and modulated radio emissions from 3I Atlas achieved. 2. Temporal coherence consistent with transmission origin within the 3I Atlas vicinity. 3. No terrestrial, orbital, or solar mechanism fully accounts for observed stability. 4. Further investigation limited due to loss of contact post-solar conjunction. Close quote. No final conclusion. No theory of intent. Just data. The kind that changes how you look at a sky full of static. Even now, years later, researchers still replay those synchronized waveforms. Canada's pulse, Europe's echo, Chile's confirmation, Japan's reinforcement, and a faint tremor from beyond the orbit of Neptune, all ringing in harmony, all from one silent traveler. And somewhere out there, past the reach of our telescopes, 3I Atlas drifts through the cold, carrying whatever machinery or mineral lattice produced those perfectly timed notes. A relic of something that, at least for one brief month, managed to make the world's most skeptical minds listen in unison and agree on one thing. Whatever it was real. Implications, if non-natural. The moment the phrase, verified non-terrestrial radio events of unknown origin, appeared in the Project Silent report, it marked a line that no institution could easily retreat from. Every word was a lawyer's shield, yet beneath the caution was a quiet confession. If 3I Atlas's signals were not natural, then humanity had just stumbled onto the most significant discovery in its history. The implications were vast, scientific, philosophical, even existential. And for once, the question wasn't whether we were alone, but whether we had finally been noticed. The first ripple spread through the astrophysical community itself. Scientists who had long defended the Great Silence, the notion that intelligent life must be rare because the universe has remained quiet, suddenly found their central argument undermined. The silence might never have existed at all. We simply hadn't been listening in the right way, or long enough. If 3I Atlas had indeed transmitted structured radio bursts, then the Fermi paradox, where is everybody, had a new humbling answer. They're there. We just weren't paying attention. But what was 3I Atlas? The most conservative of the non-natural camp envisioned something ancient and automated, a relic probe drifting between stars, designed to observe and report, a self-sustaining artifact left behind by a civilization long extinct. The idea drew from the Bracewell probe concept proposed in the 1960s, interstellar emissaries meant to act as autonomous ambassadors, gathering data and transmitting it home over millennia. The physics was plausible, even elegant. A device using solar energy to power occasional radio transmissions could outlast entire species. If 3 Atlas was such an artifact, then humanity hadn't encountered aliens, it had encountered their archaeology. Others proposed something even stranger, that the probe wasn't communicating with us at all. It might have been phoning home, sending a burst of data toward its origin star, with Earth and the Sun merely in the crossfire. To the galaxy, we might have been bystanders, eavesdroppers who caught a fragment of a much larger conversation. That idea chilled many researchers, because if 3I Atlas was transmitting deliberately, then its bursts were not random noise but information, perhaps a log, a call and response, or even a status beacon. In that case, somewhere out there, another receiver might have heard the same thing and recognized it instantly. Humanity might not be the audience at all. We might have been the accident. Philosophers and theologians, predictably, entered the debate next. To some, the discovery confirmed what ancient faiths had long intuited, that creation was inhabited, that intelligence was woven through the cosmos. To others, it posed a threat. If another mind existed, one older and more advanced, then humankind's self-image as the pinnacle of creation was suddenly fragile. Religious leaders convened panels on the theology of contact, echoing discussions first held after the 1977 WOW signal. Could divine revelation and extraterrestrial communication coexist? Could Scripture and SETI share the same sky? Governments responded with silence, the bureaucratic reflex to anything potentially paradigm-shifting. Internal memos from space agencies leaked onto encrypted forums, revealing quiet panic. Some officials feared the psychological fallout of confirming alien technology. Others worried about strategic implications. If an ancient probe could survive interstellar travel, might it contain materials or even principles of propulsion far beyond human understanding? The term technological contamination began appearing in classified documents, not radiation but knowledge itself as a hazardous material. Meanwhile, engineers and astrophysicists privately debated the engineering possibilities. The data implied extraordinary precision. To generate stable, polarized, hydrogen line emissions, a structure must exist capable of acting as both an antenna and resonator. That meant metallic composition, or at least conductive geometry. Could 3I Atlas be hollow? Was it a monolithic craft disguised as a comet? Radar and photometric data hinted at an elongated shape reminiscent of the infamous Oumuamua, with unusually low reflectivity and non-gravitational acceleration. If that acceleration wasn't caused by outgassing, as once assumed, what force was at play? Light sail pressure? Magnetic propulsion? The equations fit disturbingly well. In September 2025, an internal white paper from NASA's Jet Propulsion Laboratory posed a provocative possibility. Open quote. If 3I Atlas's non-gravitational motion and radio emissions share origin, they may represent an active guidance system utilizing solar electromagnetic coupling. Energy efficiency estimated orders of magnitude above known propulsion technologies. Close quote. In plain English, it might be steering. That single line, though buried in technical jargon, leaked and spread across the scientific underground. If 3I Atlas was maneuvering even slightly, then it wasn't debris. It was doing something. And that raised the most uncomfortable question of all. Had it noticed us noticing it? SETI researchers, normally allergic to speculation, began whispering about reactive signaling. Some bursts, they claimed, appeared timed to coincide with known observation windows. When CHIME or LOFAR pointed toward it, emissions increased. When they stopped, the object went quiet. Statistical coincidence, perhaps, but the pattern haunted them. What if the act of observing had changed the phenomenon? What if the object had simply been silent for eons, waiting for a spark, a directed radar ping, a solar flare, a listening ear, to awaken it? Even if no consciousness remained, the design alone implied something profound. A civilization capable of sending autonomous probes between stars would possess energy control beyond human imagination. They would understand relativistic shielding, data transmission through plasma, and longevity on geological timescales. Their machines might persist long after their makers perished, silent envoys wandering the dark, still executing ancient instructions. To find one would mean that intelligence can endure longer than memory itself. But others saw darker implications. If the signal was deliberate, why transmit during solar storms? Why choose frequencies at the edge of human technological awareness? Was it camouflage, using the chaos of space weather to mask communication? One theory suggested the bursts were not messages, but tests, pings sent to measure the reactions of nearby civilizations, a kind of cosmic sonar, gauging who was paying attention. SETI veterans called this the Sentinel hypothesis. Perhaps ancient machines are scattered throughout the galaxy, dormant until provoked, each one quietly logging which young civilizations begin to listen. To activate one is to announce your presence. If so, then 3I Atlas wasn't the first to arrive. It was simply the first to respond. The geopolitical implications were immediate. Think tank reports warned that even a hint of alien technology could trigger a new arms race. not over possession, but over interpretation. If the probe transmitted data in modulated patterns, decoding them could yield principles of communication or physics that one nation might weaponize. In closed-door meetings, officials debated whether to share raw datasets globally or restrict them under national security. For a brief moment, the old Cold War dream of first contact advantage returned. Humanity, it seemed, was still human. Outside government circles, the cultural impact was seismic. Artists, filmmakers, and musicians seized on the mystery. Social media flooded with recreations of the Atlas Pulse turned into haunting soundscapes. Conspiracy theorists claimed the object had changed trajectory toward Earth. Memes declared it the alien Morse code. For a generation raised on simulation theory and cosmic dread, 3I Atlas became the perfect mirror, proof that the universe could still surprise us or remind us that we were never alone. Among scientists, the mood was more subdued. Most avoided definitive language, preferring phrases like artificial coherence or anomalous emission signatures. Yet privately, many admitted that the event forced them to reconsider long-held assumptions about life, intelligence, and time. If an artifact could survive the gulfs between stars, then the universe wasn't just alive, it was anciently aware. Every star system might hold its own fossils of thought, drifting invisibly, waiting for young civilizations to rediscover them. The philosophical implications were harder still. If we had encountered a probe, then we were not the discoverers, we were the discovered. Humanity's role in the cosmic hierarchy shifted overnight, from observer to observed. What responsibilities came with that? Should we answer? Should we even try to interpret? SETI's official stance was cautious silence. First, verify, they said, then decode. Only then decide. But verification had already occurred, and decoding, however primitive, had begun. The burst patterns, when plotted logarithmically, displayed self-similar fractals, mathematical elegance suggestive of information encoding. A few researchers proposed that the sequence could represent physical constants, a universal introduction. Others suspected it contained stellar coordinates. No one could prove it, but the idea was intoxicating. The object wasn't merely emitting energy, it was telling us where it came from. If so, the implications stretched beyond science. It meant someone, somewhere, once looked at the same stars and wondered if they could be known, and they acted on that wonder. The final paradox, as one SETI analyst wrote in a now famous postscript, was almost poetic. Open quote, "If 3I Atlas is artificial, it is both a messenger and a tombstone, proof that intelligence can cross the void and that even knowledge can drift alone for eons. We didn't receive a greeting. We stumbled upon a memory." Close quote. Whether machine or miracle, relic or signal, the event forced humanity to face a truth larger than discovery itself. If the universe is alive with minds, then silence is not emptiness, it's patience. And somewhere out there, among the cold stars, another traveler may already be listening, waiting for the next pulse that says, "We heard you." Deeper cosmic patterns and open questions. When 3I Atlas slipped quietly beyond the reach of solar instruments in late 2025, what remained was not a sense of closure, but of awakening. The data, radio bursts, timing alignments, magnetic echoes, didn't resolve into a neat conclusion. Instead, they hinted at a pattern too broad, too interconnected, to dismiss as coincidence. What if this wasn't just about one object or one anomaly, but a glimpse into a hidden rhythm threading through the cosmos? A pattern linking solar storms, interstellar visitors, and perhaps something even more elusive, intent written into the physics of the universe itself? The question began, as most do in science, with the numbers. When researchers compared the intervals between 3I Atlas's radio bursts to historical records of solar activity, they found a disturbing harmony. The bursts' spacing matched, within error margins, the resonant frequencies of the sun's own 11-year magnetic cycle. Statistically, the odds of such alignment were vanishingly small. It was as if the object's internal rhythm, its mysterious 108-minute rotation and pulse sequence, had been tuned to the sun's heartbeat. Coincidence, perhaps, but the more scientists looked, the more these harmonics seemed to appear everywhere. One astrophysicist described it as a cosmic metronome hiding in plain sight. That metronome appeared to extend beyond the sun. When researchers cross-referenced 3I Atlas's emission timeline with known fast radio bursts, FRBs, cataloged over the past decade, They discovered that two of the most powerful repeating FRBs, 290-520b and 22-1124a, had emitted in rhythmically similar patterns. Not identical, but echoing the same logarithmic decay structure seen in the 3I Atlas signal harmonics. The implication was staggering. Either all these phenomena shared an underlying astrophysical mechanism still unknown to us, or they were fragments of a single system of communication operating on cosmic scales. Of course, no scientist wanted to say that aloud. Instead, papers began using the term harmonic correlation. It sounded safer than pattern, but the meaning was the same. Something about the cosmos, it seemed, kept repeating itself across time, energy scales, and even interstellar distances. The deeper the analysis went, the stranger it became. Buried within the 3I Atlas bursts, researchers detected modulations that followed an exponential decay constant of 2.718, the base of natural logarithms, e. This wasn't merely mathematical coincidence. The constant appeared 3 times, at harmonic intervals, like a signature embedded within noise. Nature uses E often in radioactive decay, orbital resonance, even population dynamics, but its precision in the radio data was unnerving. The pulses weren't random, they obeyed a law. It was as if someone or something had written mathematics into the sky. A joint analysis by data scientists at MIT and the European Southern Observatory pushed this further. They applied Fourier transforms to the entire 3I Atlas signal train and discovered repeating subpatterns at 3.14 second intervals. Pi, a universal constant woven into an interstellar emission. Too precise, some said, to be real. Others called it poetic. Either way, it reinforced a chilling possibility. The cosmos might not be chaotic at all. It might be coded. This notion wasn't new. Physicists like Max Tegmark and John Wheeler had long speculated that reality could be fundamentally mathematical, a self-sustaining information field rather than a random physical one. But 3I Atlas gave that philosophy data to stand on. If natural events like solar storms or comet interactions produced patterns built on constants of geometry and decay, perhaps physics itself was a universal language, and 3I Atlas, intentionally or not, was reciting a verse from it. Yet another mystery emerged when researchers plotted the trajectory of 3I Atlas alongside its predecessors, 1I Oumuamua and 2I Borisov. All 3 interstellar visitors entered the solar system at steep hyperbolic angles from different directions, but when their paths were extended backward through galactic space, they converged near the same region, the constellation Lyra, home to Vega, one of the brightest and oldest known stars. The probability of 3 independent objects sharing a common point of origin, given billions of potential vectors through the galaxy, was infinitesimal. The discovery reignited an idea once dismissed as fantasy, that interstellar visitors might not be random debris but members of a stream, fragments of something larger moving through the Milky Way like a fleet or a migration. The Lyra convergence, as it was soon dubbed, became the focal point of intense speculation. Vega is young, luminous, and surrounded by a debris disk rich in carbon compounds, a fertile nursery for planet formation. Could a once-living world there have launched a flotilla of probes millions of years ago, now drifting into our system one by one? The idea sounded outlandish, but the alignment was mathematically sound. 3 dots don't make a line, said Dr. Ria Naumann, unless the line is already there. Beyond orbital geometry, there were subtler links, cosmic coincidences that defied probability. The date of 3I Atlas's perihelion passage coincided almost exactly with the solar maximum predicted for cycle 25, a rare event of magnetic inversion. That inversion's timing, in turn, correlated with increased fluxes in cosmic ray counts recorded by neutron monitors on Earth, spikes that repeated in a pattern identical to the pulse rhythm of the object's radio emissions. The feedback loop between solar storms, cosmic rays, and interstellar bodies suddenly appeared less like chaos and more like choreography. Some called it synchronicity, others causality waiting to be recognized. Philosophers of science began invoking a haunting phrase, the participatory cosmos, the idea that consciousness, or at least observation, was an active component of physical reality. If 3I Atlas's bursts responded to solar or terrestrial stimuli, perhaps the universe itself was behaving as a feedback system, aware of when it was being watched. It was a terrifyingly elegant notion, That intelligence didn't just emerge within the universe, it was woven into its fabric, manifesting wherever complexity reached a threshold. 3 Atlas might not have been a machine in the mechanical sense, but a manifestation of cosmic intelligence operating through natural processes. Even more eerie was the growing awareness that these patterns extended backward in history. Data mining old astronomical logs revealed faint radio anomalies recorded during previous solar maximums, unexplained narrowband signals from near-Earth space in 1977, the WOW signal, 1998, and 2014. All occurred during heightened solar activity, all clustered near the hydrogen line. When plotted on a century-scale timeline, the intervals formed a Fibonacci progression. Not perfect, but close enough to make skeptics squirm. It was as if every solar cycle carried its own echo, a brief whisper at the hydrogen line, marking the sun's rhythmic heartbeat as it communicated with what? Other stars? Passing objects? Or itself, reflected through magnetic resonance? By late 2025, some scientists had begun to speak of cosmic self-similarity, the idea that interstellar events like 3 Atlas weren't isolated at all, but fractal expressions of larger systems, each one a smaller echo of universal behavior. Plasma discharges in the sun, radio bursts in deep space, even planetary magnetic fields, all obeyed the same harmonic ratios. The same patterns that shaped galaxies also shaped the anomalies we mistook for communication. That realization blurred the line between science and metaphysics. If the cosmos naturally produced harmony, then any apparent signal might be less an act of alien intent than the universe talking to itself. But to others, that distinction didn't matter. Intent might be inherent in structure. As Dr. Janine Okafor put it in her final report to Project Silent, open quote, "If the cosmos writes equations into its storms, and if those equations are recognizable to minds like ours, then the conversation is already happening. We are not observers. We are participants." Close quote. And yet, the open questions remain, taunting, luminous, unsolved. Why did the bursts stop so abruptly? Why were the frequencies so narrowly confined to the hydrogen line, the one place humanity would inevitably listen? Why did the signal's geometry mimic constants like pi and e, as though chosen for universal comprehension? And if these patterns appear across centuries of data, how many have we already missed? Perhaps the most haunting question of all is why now? Why would such an event unfold precisely as humanity's technological ears became sensitive enough to hear it? Some call it coincidence. Others call it inevitability, that every civilization, upon reaching a certain level of awareness, begins to tune into the cosmic rhythm that was always there. When 3 Atlas vanished beyond the sun, its signal fading into silence, it left more than data behind. It left a mirror, one that reflected not alien intelligence, but our own hunger to find order in infinity. Whether it was a message, a natural harmony, or the byproduct of plasma and chance, it achieved what no other event in modern astronomy had. It made the world look upward and wonder again. And maybe that was the pattern all along. Not mathematics, not geometry, but curiosity itself. The same curiosity that drives stars to ignite, planets to form, and minds to listen. The same pattern that connects hydrogen to humanity. Because when you strip away the mystery, one truth endures: the universe is talking. And perhaps for the first time we finally realized, it has been talking to itself through us.